Welcome back to Ask a Scientist Gaming, where we combine mediocre gameplay with expert science. I'm Ken Hansen, Associate Professor in the Department of Chemistry and Biochemistry at Florida State University. I do light chemistry, which means I use photons to drive chemical processes, breaking bonds, converging it to like electricity or mechanical work. But more importantly, joining me today is Dr. Jeremiah Murphy. Jeremiah, if you wouldn't mind introducing yourself.
Hi, I'm Jeremiah Murphy. I'm also associate professor in the physics department, and my specialty is in astrophysics. In particular, I study the explosions of stars using both theory and supercomputers to predict which stars would explode. And we also use data from space telescopes to constrain which stars have actually exploded.
Very cool. What do you typically teach?
I teach a range of things. Right now I'm teaching Astronomy 1002, which for our university is Astronomy 101.
Mm-hmm.
So that's a lot of fun. It's, I try to make it fun and informative at the same time. I also, on the other end of the spectrum, I teach general relativity. So Einstein's theory of general relativity, which is, warping of space-time, lots of tensor calculus and black holes, etc.
That's graduate level?
It is graduate and undergraduate level, yeah.
Very cool.
Yeah.
All right, equally important, what game are we starting with?
We're starting with StarCraft.
StarCraft. So this is one of your undergrad favorites? This goes back.
Yeah, actually, it is one of my undergrad favorites. All right, so I'll just start in single player. Let's go to original. And here's me, Curious Maya. If you ever see Curious Maya out there, that's me. I don't think anyone else is taking that handle.
But they're going to find you and talk shit. And just like have so much sex with your mother. This is the internet, Maya.
Yeah.
Already made a mistake.
All right, let's move past all this introductory stuff.
Yeah.
All right, we'll skip the tutorial.
So did you play this online, like versus people? Or how hard did you go?
I did, yeah. I played versus people, and which was a lot of fun. That was a lot of fun. But I think at that time, playing online was new.
Yeah.
And so playing against the AI was most of what I did.
No, it makes sense. I mean, especially how deep the rabbit hole online went.
Yeah.
Right?
Okay, let's see. There's over here. I'm guessing since I didn't pay attention to what I should be doing, I'm supposed to be going down here somewhere. So let's go ahead and do that.
So real-time strategy, this was your game of choice? This is...
Yeah. Yeah. I don't know why. I mean, it ended up being a game of choice for a lot of people at the time. I don't know what it is that attracted so many people. I mean, StarCraft, it's set in space.
I mean, yeah, it was huge. It still is huge, especially Korea. Like, people dying playing the game for 16 hours straight.
Oh, Lord.
Yeah.
Let's not do that tonight.
Yeah, exactly. Let's just do 3 hours and call it a night.
Oh. Can we tech? There we go.
Oh, man, we got our first spam chat of the night. Want to increase your number of viewers? Thank you, bot.
All right.
Yeah, I did. My real-time strategy choice was Age of Empires 2.
Oh, yeah.
Like castle storming and archers and whatnot.
Oh, that sounds fun.
Yeah. That was a good... I think it was about the same time as this one. Oh, now I gotta play moderator.
All right, I gotta check out the mission objectives. Build a barracks, train 10 Marines, and Rainer must survive.
So I don't remember. This one, you harvest stuff, you build stuff, you select soldiers.
Yeah, you basically, I don't know, it's like SimCity in space, I guess. Yeah, you harvest stuff, and then you build buildings, and you up your weapons and your people and stuff like that. There's a narrative arc. Can I remember what the narrative arc is?
There's lore. Can't appreciate the game unless you know the lore. All right, got rid of some spam there. All right, so this is our first stream of the new year, actually. Not only that, this is the 50th stream of Ask a Scientist Gaming.
Oh,
So,
cool.
you have stumbled into 2 milestones. Congratulations.
All right.
Cheers. And
Cheers.
again, this among all the things going on in your life, we appreciate you joining us for a little bit of gaming. And
Yeah. Absolutely.
spending some time. Note everything will be recorded and on YouTube, so anything you say and do tonight
Be careful.
against you.
Yeah.
We literally have dozens of YouTube views, so be forewarned. But we live in Florida, so who knows what that manifest as.
Yeah, right.
But yeah, anyone just joining us, Ask a Scientist Game, mediocre gameplay expert science. Our guest today is Maya Murphy. He's settled in a little bit to playing some StarCraft, the original version of StarCraft. And so if you guys have any questions, throw those in chat. Maya will be happy to answer them. He's an expert in astrophysics, modeling supernova explosions, as well as black hole formation. I mean, pretty much anything astrophysics, even casual physics. Maya's happy to answer those questions. Supernovae. The plural of supernova is novae.
Yeah,
I did not know that.
Yeah, supernovae.
I would have gone with novas, supernovas. But,
Yeah, it's kind of weird. The etymology of that's kind of weird, right? I mean, super is certainly not. Is Nova Latin? I think it's Latin. I think today I said it was Greek. I think it's Latin. It's one of the two.
Somebody double check.
Yeah.
I'll take a look. We'll see. I'll double check you. I mean, so physics, you guys get the most badass names of things, right? Like it's super and giant, and it's like everything
or
is
Big
epic.
Bang.
Yeah, exactly.
Everything is epic.
Big Bang. It's just straightforward. Fission, fusion.
Yeah.
Strong, weak, gluons.
Oh yeah. So if
gravitons.
anyone has questions, do we have people online yet? Yeah. If anyone has questions about the recent fusion results.
Oh, you're familiar.
Yeah, I am familiar with that, and I have opinions about it. So if you want to know what Jeremiah's opinions are about it, feel free to ask.
That is awesome. All right, Reese's Pieces wants to know, are there any misconceptions people have when you tell them you're an astrophysicist?
So the first thing that usually happens is, oh wow, or the second most common one is, what is that? And then I'm like, astronomy.
Yeah.
And then the third most common misconception is astrology.
I was going to say, I'm a
which I
Gemini.
don't do that.
Yeah.
Fortunately, most people don't. Fortunately, that's not the number one misconception.
No, that's fair. I mean, so your airplane conversation, like, what do you do? I'm an astrophysicist.
Yeah.
And then it's, what are the odds somebody knows what that is?
That's a good question. I would say 85%.
Okay.
Yeah.
So Carl Sagan has done you well.
Yes, exactly.
Neil
Yeah.
deGrasse Tyson.
Oh, yeah. Carl Sagan started it, and now Neil deGrasse Tyson
Mm-hmm.
is taking up that torch and doing quite well. Yeah.
That's fun. So
Yeah.
then there's 10% that don't know.
And then there's a ton of people in all the communities where, we call astrophysics the gateway drug into science. So
Yeah.
it's the easy one to
Yeah.
get to do popular science kind of stuff and get asked to do interviews or whatever.
Yeah, anyone gets to look up at the stars and say, what?
Yeah, yeah.
It's readily digestible.
Yeah.
No, it's fun. As a chemist, I'm jealous of that because we don't have a lot of popularizers in chemistry, right? We had like Linus Pauling, right?
Yeah.
But since then, it's not. You can list the physicists, the Stephen Hawkings, the Carl Sagans.
Yeah.
I think it is because it's more digestible, but the gateway drug, I like that. Cuddle Puppy, I guess it's time to bring up the physics joke. I'm curious what the physics joke is.
I am. Me
Let's
too.
go, Cuddle Puppy. Impress our guest. Cuddle Puppy is one of our regulars.
Okay.
I mean, so the people, man, there's a great YouTube clip. There was like a dating show or something, and like the male lead on it was like, I'm an astrophysicist, and they made it response was, oh, I'm a Gemini, what are you? And I was like, well, that date's done. Cuddle Puppy, is it true physicists prefer to work in a frictionless vacuum? If so, how do you plan standing up and breathing during your experiments?
That's just. I'm a little disappointed. I'm laughing. Well done.
Oh man, do you know the spherical cow joke? Have you heard this one? It's another physics one.
Okay, go for it.
So there's farmers having issues with the cows not producing enough milk and things like that. And so they go to the local university and go to the physics department and say, I need help, solving my milk production issues. And the physicists go away, and 2 weeks later they come back to the farmer and they're like, we have solved your problem. All we need to do is treat your cow as a frictionless sphere. That's the spherical cow.
All right, there we go. Okay.
So, wow, we're just ripping on physicists right off the bat. Cuddle puppy, look what you started. That's the physics joke. That's the only one I know. All right, but in general, is it a positive response? People that know physics, like, they obviously think you're brilliant right off the bat. And
Yeah, that is the
must be
common
really
misconception.
smart, right? that's fair. But like, are they,
Actually, maybe that is the common misconception. Actually, is that we're all innately brilliant.
like, are they curious? Do they follow up
Yeah,
with
absolutely.
exchanges?
Yeah,
And-
absolutely. So the questions run the gamut from, I'm gonna say, at first glance, a naive question, but then when you think about it, it's like, oh, that's a really
Profound,
it's a
yeah.
profound question.
Yeah.
Like, that's a new way to think about it, and then you start digging deeply. So that's one of the questions, and then so there's a lot of interesting questions about like what's hot, like maybe dark matter, dark energy. What's all that about?
Fusion, fission.
Yeah, exactly. Or what's the latest thing that's gone by? Like maybe if there's a comet that's gone by, or there's an asteroid that's may or may not be hitting Earth. They get those questions, and then there are people who come to you with their I'll call them cosmological philosophies of the universe.
Yes.
And I'm not certain what their intention is.
Yeah.
I think it's mainly they just want to be heard, which I'm happy to entertain that.
No, that's fair.
Yeah.
I mean, we've had our share. So Mayo's one of our original in-person Ask a Scientist guests, actually. So yeah, we've seen a lot during that endeavor.
Yeah.
This one, internet, we'll see what they come up with these questions, but physicist jokes. I mean, I'm a bit jealous of the response you get, because when I say I'm a chemist, they're like, I hated that class. And
Yeah.
It's like the end of 80% of my conversation.
Yeah.
Which I'm okay with. I'm an introvert. Let's not talk at all. But once in a while, you get someone that's like, oh, yeah, that's fun. That's exciting. But like when you go to a doctor and they're like, I hated chemistry, I'm like, oh,
Ooh.
this is a red flag.
Oh yeah.
Oh, that's good.
Yeah.
Former students.
I got a problem here. I need more supply depots. I stalled out. Sorry for those of you that were really enthralled with my StarCraft playing.
Yeah. Well, you can explain to them what you're doing, because I'm sure this.
Okay, yeah. So in StarCraft, you have to have a certain number of supply depots per people. So right now I've maxed out my supply depots. Presumably you get supplies from the supply depots.
Yeah.
The objective of this particular one is to build a marine barracks. If any of you have ever played Starship Troopers, I'm almost 100% certain this game was based upon Starship Troopers. Like that
You're talking about the movie?
Yeah, the movie.
Yeah.
Sorry, yeah. I didn't mean the game. Yeah, the movie.
It was a book, right? It was a book first, and
I
then a
think
movie.
so, yeah. Yeah, when I first saw that movie Starship Troopers, I don't think I really appreciated just how clever it was.
Yeah.
And then I went back and watched it, and I was like, oh, this is nice.
It nails some satire.
Yeah,
Like,
it's a really strong satire.
yeah, exactly. Like, we were dumb and young, but now it's just like a hammer to the face.
Yeah,
It's like,
exactly, yeah.
here's your propaganda.
Yeah. Unfortunately, it was, very prophetic.
Yeah, no, exactly.
Recently.
No, it's tragic. I mean, it's gone back decades at this point, right? All right, we should probably tell people we're drinking as well.
Transmission. Comlink established.
Angels Envy Bourbon. So this is just a favorite of yours?
Yeah. So I grew up in Kentucky and Washington State, two very different places. And so, yeah, I appreciate bourbons. It's been really interesting seeing the bourbon industry in Kentucky just balloon. Mm-hmm. It's a massive industry now. I think it's like a $500 billion industry per year. They can't even keep up with the world demand on bourbon. And the thing is, it takes years to develop, bourbon. So
Yeah.
They basically have a backlog, and so they're building all of these bourbon factories. Essentially, they're basically barns with barrels of bourbon in them, and hopefully for the economy of Kentucky, it doesn't tank.
Yeah. I was looking up on this one. Like it's vanilla flavor. It's a little bit fruity. That they age it in like port barrels.
Yeah.
Like that's an amazing skill
Yeah,
set.
it's a relatively modestly priced bourbon, but it has a really nice flavor, and it's not like the aftertaste isn't too strong. All right, I better check out the mission objectives. Okay, eradicate the alien infestation. Raynor must survive. So that's probably the most fun part of this game is you just get to try to demolish aliens, insect-looking aliens.
According to Reese's Pieces in the book, the Starship Troopers book, it was not originally satire. The movie did that.
Oh wow!
Wow, I don't know if I want to read that book because if it's taking that literally, that's
yeah, or
like,
seriously, well, that, yeah.
wow. Oh, all right, good to know. Is it a good book, Reese's Pieces? Have you read it?
Not enough
Is it worth like I like sci-fi regularly, but I've never read Starship Troopers.
Yeah. So do you read sci-fi regularly?
So audiobooks, I bike to work
Yeah.
occasionally, and so yeah, audiobook is my main thing. Like I guess the most recent sci-fi right now, I'm on the Stephen King. What is it called? Fairy Tale, like his most recent one. It's like a fantasy. It's not a traditional Stephen King book, so it's been a lot of fun. But
Yeah.
like recent ones, Three Body Problem. I finished that series.
Oh yeah, I've heard of that one. Actually, I had a student give me a book as a present and recommend it. Yeah, I'm actually looking into like the three-body problem is a very famous problem in mathematics and in physics, and actually in my field. Like that's where it starts, and so I am very intrigued by it. But I haven't read the book yet.
Yeah, I mean it's talking about essentially multi-star systems
Yeah.
and the implications of that, and it's fun. It's a little bit janky in the read because it's originally Chinese, and so
Okay.
the translation, I think some of the flow was lost. But I really like sci-fi books that kind of break the idea. The other one is Seven Eves. I don't know if you've heard of this one where the moon explodes and they have to migrate to space.
What's it called again?
Seven Eves.
Seven Eves.
So like Adam and Eve. There's
Oh, okay.
seven Eves that I won't give away too much spoilers. Don't want to ruin anyone's book reading, but yeah, Seven Eves is another one. But yeah, I love a good sci-fi, and usually they're space related, right?
Yeah. Yeah. So for me, for a long time, it was hard for me to read sci-fi because I had to do so much suspending of disbelief
Yeah.
to lean into it. But I always enjoyed fantasy because there's no point.
Yeah.
I mean, like it is fantasy. That's the point of it.
I suppose there's like an uncanny valley of physics knowledge that you didn't want to live in. That makes sense.
Yeah. And so, but I think recently I've, just I guess with age been.
You just gave up.
Just gave up. Yeah, just enjoy the book for the read.
Yeah.
But there are a lot of books these days that are getting the science aspect of the sci-fi a lot better. Like The Martian.
Yeah.
That one, I read that. I saw the movie, then I read the book. I really appreciated that one. Although that book, everything about that movie and the book is spot on, except the very first scene that sets up the drama. It actually wouldn't. So I don't know if people.
Which scene is that? Yeah, go ahead.
Okay, so
Spoilers for a movie that's 5
yeah.
years old.
Well, I mean, it's in the first 10 minutes or whatever. So, by the way, those of you will notice I'm not very good at multitasking. So I'm either going to be talking or playing.
It's fine. There's wait time in this game. I think it's a good choice.
Yeah.
Building.
Yeah. So, so in the first few minutes, there's these astronauts, they go to the Mars and they have a rocket and it's time for them to go. Well, they're getting ready to go, but then a storm blows up, which there are storms. There are like planet-wide storms on Mars when they whip up. So that's realistic. And then the storm is blowing so hard that it starts tipping the rocket over. And they're like, oh, we got to get on the rocket and we got to blast off before it tips over. And so they're like tipping over and then starting to blast off. Like, how's that going to work? The ballistics, is that going to work? But that's not the main problem. The main problem is the atmosphere on Mars is something like 1,000th the density on Earth. So you take a hurricane, right? The force of the wind is the mass density of the wind. So basically, the mass density times the velocity squared is the force. And well, the density on Mars is like, so even if you have hurricane winds, there's so little density. It's not clear to me would actually even tip over a rocket. Like the rocket may not feel anything. So the whole, like everything else is fine, but the whole premise of like why they got in trouble probably would not happen.
That's interesting. I mean, so the alternative is the air velocity is faster.
Really
right?
fast. I mean,
they have to be. I guess you can do that math, right? It's squared at 3 times faster, right?
Yeah.
So
yeah.
I don't know what dictates that on Mars.
Well, so it typically what dictates winds are, thermals, so the sun heating. And I seriously, given that Mars is farther away, I seriously doubt the wind speeds are higher. They're probably lower.
No, that makes sense.
Yeah, so.
No, that's. I mean, you just.
Although you could get some cyclonic activity. I don't know. I don't know. Yeah.
So you segued into one of my favorite questions because I've seen a lot of movies. And one of our go-tos is, you watch movies and sometimes you're cringe, sometimes you're excited. So, like, what movies get your expertise right and which ones get it wrong? And so Martian gets it right.
Yeah, for the most part, yeah. There's one actually that's even closer to the science that I do is really darn good. It's Interstellar. So the story behind that one getting started is let me make a bunch of people and let me just mindlessly send them off to go attack things while I'm talking.
Let's do it. I appreciate you're conscientious of the entertainment value of your gameplay. Good or bad, stuff will happen, ladies and gentlemen.
Yeah, exactly. That's actually one of the things I really appreciate about this game is you just there is some strategy. Like it is useful to have some strategy, but there's also an element of like, all right, set things on autopilot, set up a decent base strategy, and then go, and then let your little bots do the work for you.
So have you watched? I mean, they have like $1 million tournaments for StarCraft at this point.
Do they really?
Like, Korea is
I should probably
but
watch that.
The strategy and how good they are at managing, and I mean,
here's a bunker.
It's breathtaking.
Looks like there's some people here I can go befriend.
All right, so Interstellar, that got it right, modeling black holes.
Oh, yeah. So, let me bring these guys back here. Actually, let me put them here. I'm gonna have them mine some gas. Yeah, Interstellar got a lot of the physics right. The way that got started was, I'm gonna forget which. I think it was Kip Thorne. Yeah, Kip Thorne. He had this idea for the movie, and he wanted the central star of the movie to be a black hole, which it kind of is. But they put it, within Hollywood, and so I think Chris Nolan was the director and writer for that.
Yep.
So he gave it a story that would actually sell. Much of the physics that deals with the black hole is spot on because Kip Thorne is one of the we have a book called Gravitation that is deals with all that physics, and he's one of the main authors of it. So he's very active in the field. So we developed that. They even developed some new technology to simulate what a black hole would look like for the movie. So a lot of that is real physics. They turned down some stuff just so you could actually see it.
Yeah, that makes sense. I will say, though, one thing I hate about that movie is that the most powerful force in the universe.
Oh my gosh, the fifth force of love. Yes, that was okay. Okay, yeah, that was super corny, and I did not appreciate that. I was like, all right, come on, guys.
I was like, you're talking about time travel and intergalactic forces and
I mean, that's even
it's so disingenuous to a scientist. She was an iconic character, and then just why?
Yeah, and then it's just corny just in general.
That's true.
Just not even to a scientist. That line is
yeah. What?
I don't know.
So that one has both the best and the worst of all sides.
Yeah.
Are there any ones in your mind made you cringe? Anything that's just wrong?
Movies?
Yeah. So there's a recent movie, Moonfall, that was on Netflix. Did you see this one?
I did not see it, no.
Man, it's amazing. Amazing in a very bad way. I recommend you watch it.
Okay. Moonfall. Oh, wait. I started to watch it. I think I turned it off in like 2 minutes.
Weird. Why?
Yeah.
Not enough minerals.
That one, it goes off the rails. It breaks physics. If you're willing to suspend, it might be a good time. I mean, there's some that, like I said, the uncanny valley, right? If they screw up the science so much, you can't even care anymore. Right?
Yeah, yeah.
But if they're like slightly wrong, or they tried to be, somewhat right. I think Star Trek did it well, because they were like, this is the, accelerator drive, and it just does that.
Yeah.
Like,
Well, so that's actually the thing that makes so the distances between stars is immense.
Yeah.
It is immense. So if if you can do the calculation of what it would take to get to the nearest star within 80 years human lifetime, the amount of energy, you basically would have to build a city in space and then power the thing with an antimatter drive, which like we just don't have any of that stuff. And yeah, so the amount that it would take to get there. So with Star Trek, they had to solve the main problem, which is the distances are vast, the energy required is vast.
Yep.
And then once they solve that, then they can start traveling across the galaxy.
Just 2 words: warp drive.
Exactly.
Does that.
Yeah.
It just fixes that. Let's assume that's correct, and then everything else falls into place.
Let's hold on to that warp drive. There's one of the questions that we have. I don't know when we're going to do that. Kind of deals with that. All right, let me check.
Predictions? Which one?
The last one. It may not seem like it, but the last one connects to it.
I'll come back to that, because I don't want to give away. We might have given away too much of an answer on that.
No, definitely not.
We'll give it 4 minutes. At 8:30, we'll do a prediction. But yeah, if you guys have questions about astrophysics for my Murphy, he's happy to answer them. Put them in chat. I promise we'll get to them. If I miss them, I will come back. Yeah, we're going to cover many things.
It's time to
throughout
go
the night.
eradicate some aliens.
Yeah, do it.
Additional supply depots.
Oh, not enough supply depots.
So I looked up how long these games typically take. The world record. How long do you think the longest StarCraft game ever was?
What? Long? Why
Yeah.
would you make it long? I don't know, days.
Two people competing in a professional capacity, and the answer is 3 hours, 5 hours of game time.
Oh, wow.
Not too dramatically long, but also 3 hours.
There, I was just sitting there, yeah.
Yeah, well, then they're
Actually,
like
that's surprising.
high performance, like, these guys are experts, and they're
Yeah.
just hammering each other for 3 hours. It's pretty intense.
Yeah, I'm not being very efficient right now.
No worries.
Usually when you're playing this game, you're like zooming around everywhere.
It's okay. No worries. Blame it on the ethanol. All right. We have raining comments. Hi, Professor Murphy. I'm from your astronomy class. I was wondering, what happened when you enter a black hole? I hear the term spaghettification thrown around a lot, but I don't necessarily know what that means.
Okay. So spaghettification is
Spaghettification. Thank you.
it's kind of what it sounds like. As someone falls in a black hole, they just get stretched out. Let me describe what that is a little bit. So it has to do with tides. So, we have tides on the Earth, and then there's actually the Earth is causing tides on the Moon. But so, like, the Moon is causing tides on the Earth, and what causes that is the side of the Earth that's closer to the Moon is a little bit closer, which means the force of gravity onto that part of the Earth by the Moon is a little bit stronger. So it causes a squeezing in that direction of the Moon. And so that's why we have tides on the planet, and most of that squeeze gets absorbed into the water instead of the rock on our planet. Now, the closer you get to something, the stronger the tides get, and black holes are so compact and so dense. So, like for example, if you were to squish the sun into a black hole, it would only be 3 kilometers across. So you can get really close to the black hole, and that's when the funky stuff happens around black holes.
So you're talking the event horizon?
The event horizon, that's right. The size, when I say size, it's the event horizon, which is kind of an imaginary surface. But so as you fall closer and closer and closer to a black hole, like a stellar mass black hole, the difference in force close to versus far away is so strong that it overcomes even the chemical bonds in your body, and it would rip you apart. But bringing it back to the movie Interstellar,
time dilation.
Yeah, there's also time dilation. Yeah. But bringing it back to the movie Interstellar, In that movie, spoiler, I guess.
Yeah, go ahead. It's old enough.
Yeah.
Zero remorse on this.
Yeah.
Go watch the movie.
So there's an event where the person crosses across the black hole, and people are like, wait, what about spaghettification? Well, it turns out a supermassive black hole is actually big, and the tidal disruption at the edge of it is not strong enough to rip apart a person.
Huh.
It could rip apart a star, which is held together by gravity, but it can't rip apart chemical bonds. And so supermassive black holes, even though, they're really massive, they just don't have strong enough tides to rip things apart. So spaghettification doesn't happen with supermassive black holes. It would only happen with what we call stellar mass black holes, so stars that have collapsed into black holes.
That is intriguing.
right.
Cuddle Puppy has an alternative theory. It makes you Italian. Thank you, Cuddle Puppy. You learning how to teach your class tonight? It makes you Italian. Don't get too close to the event horizon. It makes you Italian.
All right, I need to take these bots up here, mine some minerals. These guys are doing nothing.
I mean, so on the bad movie front, so astrophysics obviously directly related, but physics in general. So if you watch any of the Fast and Furious movies, obviously physics is completely abandoned. Does that bother you? Like when Newtonian physics just goes out the window?
Nah, it doesn't really bother me. Yeah, that's fine.
Yeah,
it's I don't know. What is fun though is when people try. Because then the movie is unique.
Yeah.
I don't know if you ever noticed, like when, for example, when fight scenes are not grandiose, but it's just a couple people just slapping at each other.
Yeah, like it's a real one.
It's real, and raw. It feels striking in some way. When people do that with physics, it feels striking in a way. Mm-hmm. So I do appreciate that.
Yeah, it's not as sexy, but it's much more believable. It's much more.
Yeah.
No, that's really fun.
What was that series? It's not on Netflix. I think it's on. It's the one where there's people on Earth, there's people on the asteroids, and there's people on Mars, and they're fighting each other.
I don't know. How old is it?
Very recent. It was a book that was turned into a series.
Huh.
I think it's on Amazon Prime, not Netflix. Anyway, I'll think of the name of it in a second.
Yeah. Well, if anyone knows the name, throw it in chat. We'll look it up.
One of the cool things, they do a great job of what it would be like doing space travel in space. There's a lot of inertia you got to worry about. They also do really cool things with orbital dynamics in that series.
Dune. Dune is not a recent one. Anyone that's seen, who is it? David Bowie, the original 1970 Sting. That's what it was. It was Sting.
Yeah.
But also based on the book. But the new Dune was a lot of fun. I really liked it.
Yeah, it is a lot of fun. I like Dune a lot, actually. One of the things that I think gets overlooked a lot about Dune is it's more about inner space than it is about outer space.
Yeah.
It's about awareness more than anything. Mm-hmm. And there are some nuggets in there in that movie in terms of awareness. Like, I mean, they take it to the nth degree and turn it into a religion and a mysticism. Yeah. But there's a lot of interesting things about awareness.
Yeah. Well, I mean, they also integrate like the geopolitics and like the social aspect. Like, it's such a fun story.
It is,
and I really like how anyone that's seen the original movie, watch the new one. I feel like that captured more. I hope they do the sequels. I think they're working on them.
You know what's funny is I was young enough when the first movie came out. I was alive.
Yeah,
and I watched it and I enjoyed it. I was young enough that I enjoyed it.
When was the original one?
I think it's like 1980. No, yeah, 80, 84.
The novel is 1965.
Yeah, the novel is quite early.
1984. Yep.
Yeah.
So I was 2 years old. So we started. We're pretty close in age.
Yeah.
Yeah. Dune 2021. Raining comments. I looked up the show you were talking about. Is it The Expanse?
Yes, that's it. Yeah, The Expanse. Yeah,
that's worth a watch.
Yeah, the orbital dynamics in that one is pretty awesome, especially how, Yeah, the orbital. You just watch like how they do the orbital dynamics in there, and they also have no sound when they're doing outer space stuff. Oh, that's actually that used to be my biggest pet peeve.
You could hear it.
Yeah, I think
No one can hear you scream, ladies and gentlemen. The Expanse. There we go. What about Gravity? Did you see that one? The Sandra Bullock and
I did. I don't remember it, which must have meant it was
forgettable.
yeah.
Not bad, not good. Somewhere in between.
So this is one of the things I like to do is I just like to make troops and then send them off to.
All right, diverting off the movie track. Ethan, welcome to the stream. It's great to have you here. Do you think the James Webb Space Telescope is as significant as it seems?
Oh yeah, oh yeah.
Are under attack.
That thing is going to give us so much information about the universe.
Well, let's contextualize this. I'm going to back up the question a bit.
Sure.
How much did a Hubble telescope change astrophysics?
Oh my gosh. I don't have anything to quantify it, but I did hear once it's one of the most cited instruments in human history. So there you go.
That's pretty good context.
I don't know if that's actually true. When I heard that, I didn't double check it, but
Yeah.
it's not, if it's not true, it's not far off from the truth kind of thing. But yeah, there's so much that, so
I mean, so like if you had to list major breakthroughs since Hubble, like what are, I guess there might be subtle enough, but is there
Well,
a layman's version of that?
yeah, let's see. Okay, so it was designed to really get an accurate answer of how the expansion rate of the universe. That's what it was designed to do, and it did well at that. It has discovered so many things. Let's see, we have seen some of the first galaxies with the Hubble Space Telescope. Not quite the first ones, but like way back when. And we learned a lot about like how galaxies form and how they merge together.
Was Hubble the first exoplanets? Or was that
No,
that was terrestrial based?
no, that was
telescopes?
terrestrial based. Yeah.
Okay.
Yep.
That's fun. All right, so going on to the Webb telescope, obviously this is going to change
Yeah.
everything.
So the James Webb Space Telescope is actually an infrared telescope. So it's designed to observe the universe in the infrared. And so there's, the visible spectrum. And on the red side of the visible spectrum, there's the infrared. So even more red than infrared. Sorry, even more red than red is the infrared. And the reason that's useful is I mentioned that the universe is expanding. Well, as you imagine way back when, you had galaxies that were forming, they're emitting light, and as that light is traveling through the universe, as the universe expands, it expands the wavelength of light with it. And so it makes the wavelength longer and longer, or in other words, redder and redder. And so these galaxies that were glowing in the visible, their light gets red shifted or expanded into the infrared. So if you want to see the first galaxies, you have to see them in the infrared. And that's what the James Webb Space Telescope was designed to do, was to see these first galaxies. So I'm excited about that. There's a lot of interesting conundrums, like if we want to stick to the black hole theme. Oh, wait. Actually, that's going to be part of one of our questions.
Yeah. Well, let's go.
This one, the top one.
Well, let's go with the early Big Bang one.
Yeah.
We totally talked about this one. So, ladies and gentlemen, we're going to do a prediction. If you guys aren't following the channel, click the follow button, get your 300 standard internet units. These points are absolutely useless for anything outside this channel, but you can use those points to make us drink. You can request a factoid, highlight a message, unlock an emote. But you can also gamble on our scientific questions. So we do predictions. Usually on Twitch, predictions are for like game outcomes and will Maya beat whoever. But in this case, we use them for science questions. And so we're going to throw up a science question right now, and you guys have to answer them. Note that you are on Ask a Scientist Gaming honor policy, so you don't look up the answer, just guess based on what you know, whether you know the answer or not to this question. So bet your points according to your confidence. So the question is, in the early Big Bang, was the expansion faster than light? Is there any additional context you want to give on this, or is that enough?
Yeah, the expansion we're talking about is the expansion of the universe. Did the universe expand faster than light or not? True or false?
In the early Big Bang. And so, yeah, bet your standard internet units based on your confidence, and we'll see where this goes. So Maya gave me all these questions without answers, so I'm kind of happy I don't know, because I kind of want to know how I would guess. Unfortunately, I have infinite internet points, so I can't gamble, but I look forward to you guys guessing. If you guys aren't familiar with this, at the top of your chat, there's a predict button. Click that predict button and to just bet as many points as you want one way or the other, depending on your confidence. Again, this is just for fun and pride and imaginary internet points.
Okay. So one of the annoying things when you have to like eradicate all the aliens is like there's often some hiding in these fog of war areas.
Oh, and you have to reveal the whole map.
Yeah, you have to reveal the whole map to find them.
But once you reveal, it stays revealed?
Yeah, it stays.
Okay.
Well, in a way. So like the terrain, the general topography.
I see.
But you have to have troops to have intel into what's actually in that area.
I see. And there's like scouts you can send and things like that.
Yeah, that comes later. Right now, I just gotta send my Marines, my dutiful Marines.
Starship Troopers. Would you like to learn more? Oh, I like it. All right, you guys have about 15 seconds left to gamble according. We have a 50-50 split on this one. The chat is...
Oh, that's awesome.
Like exactly 50-50. They gambled matching numbers, presumably.
Oh, wow.
So I'm excited. Early Big Bang expansion faster than light. So one thing that I learned about these questions is there's a lot of meta information. Yeah. And this is one of those I'm like, why would he ask it if it wasn't counterintuitively true? So I would guess true. What is the actual outcome? Go ahead.
Yeah, the answer is true.
Faster than the speed of light.
Yeah.
And Einstein says you're wrong.
No, actually, no. So this is where, okay, so now we'll back up. I'm guessing that people are aware that it is often said that you can't go faster than the speed of light. That's true. Excuse me. You kind of burp the dangers of drinking beer with the microphone.
So now we've moved on to Oyster City.
Yeah.
And we're onto their German-style lager.
All right. Actually, while we're on Oyster City, I will say my favorite beer on the planet is made by this company, Oyster City. They are a local company here in Northern Florida, Apalachicola. And the best beer is the Hooter Brown. I don't know what they have done. They have the recipe right. They're nice, simple beers where they just get the recipe right, and especially their Hooter Brown, which is it's a brown ale.
Yeah, unfortunately I couldn't find it. Is that seasonal or it's just not?
No. It's one of the most. It's the most popular beer they have. Like that one put them on the map.
Oof, 8.5%
yeah,
alcohol.
Yeah. It was gonna knock us flat if we did that one.
That's fine. Yeah, we're going with the Tate's Hell's German-style lager.
Yeah.
So Oyster City. I didn't know they were local. I knew they were Florida, but I didn't know they were that close.
Yeah. So, all right, going back to speed of light. How is it the universe could be expanding faster than the speed of light? So, yes, things can't go faster than the speed of light locally. But it turns out space itself can expand faster than the speed of light. Oh, look at that. I won.
Congratulations. We got a victory. Let's do good game, Bowser.
Right.
Well, cheers. And Reese's Pieces has requested to take a drink. Maya, cheers. Thank you for joining us. Reese's Pieces, hopefully you have a drink in hand. Sure, it's a school night. It's a Wednesday night, but might as well have a little drinking and fun and gaming entertainment. Thank you for joining us, Reese's Pieces, as always.
Yeah. You know, this is something that's fun about this game, StarCraft, is this is one of the first ones that they had it was like a movie production. They put these little animations in between the segments to fluff up the story.
Yeah.
I remember when this game came out, they had a trailer for the game. I'm pretty certain this was one of the first ones that did trailers. Blizzard made this, right?
Yeah.
The Behemoth Blizzard.
Blizzard.
I think this is the game that put them on the map with StarCraft.
Yeah. All right. Sorry to interrupt. Back to universe expansion. So the universe can expand.
Yeah, so space-time itself can expand faster than the speed of light, but things moving within the grid locally cannot move faster than the speed of light locally. Mm-hmm. That's the only restriction. And so what happened in the early Big Bang is a period called inflation. And there's a lot of evidence that suggests that the universe expanded exponentially by a lot, like at least e to the 60 times. So
That is a number.
yeah, it's a number. It's a big number.
Jeez.
And so
8 to the 60.
yeah. So in that, as it's doing that e to the 60, at some point the expansion goes faster than the speed of light, and it needed to do that to explain some of the things that we have today. I don't know if it's worthwhile going into those, but that's just a little factoid. If anyone wants to know more about inflation or Big Bang, we can dive into that.
I mean, so that's like my superficial understanding of relativity in physics. I mean, there's a problem with frame of reference, right? And that's defining, you're at the front of the rocket that's going the speed of light and you turn on the flashlight. Frame of reference matters.
Yeah.
How do you frame of reference discussion the universe expanding? Like there's like a center point? Like how do you think about that?
No, so what you're getting at is relativity. Like actually, the name relativity is motions are relative. You can't tell absolute motion.
Yep.
You can't tell absolute motion. So all motions are relative. And when it comes to how deep do I want to go? It's really fun and fascinating. So it comes to what are called inertial reference frames versus accelerated reference frames. So an inertial reference frame is like, imagine you're out in space and you're just floating there. And then you push a ball, right? You have a ball, it's floating there, and you push it, and it keeps going. And because of inertia, it just keeps going. That's what we mean by inertial reference frame. So any reference frame in which you do that same experiment, turns out it's exactly the same. It's an inertial reference frame. In other words, it's a freely floating frame. So now imagine you're in a box falling through gravity, through Earth's gravity. You're in a box, and there's no windows. And when you're in this box and you're falling, you're in free fall. And so you're sitting there floating, and you have a ball there, and you push it, and it just moves like as if it's it's just inertia. There's no external forces. So this freely falling box is an inertial reference frame. In other words, it's a freely floating frame. And so those are the kinds of frames that you have to think about when you're thinking about like Big Bang. There is no center. It's just the difference between accelerated and inertial reference frames.
That's a fun abstraction.
Yeah.
I like that.
So, and it turns out that, let's just go with this reference frame. So let me go ahead and start this just so we can watch something over here. So an accelerated reference frame. All right. So, we need to discuss the other one. Imagine you're in a rocket, has no windows, and you power the rocket, so you're accelerated. Well, you could imagine just like taking the chair and then putting down on the bottom, but because it's accelerated, you can actually sit on the chair, right? So that's an experiment, sitting on the chair. That experience of that acceleration, you just sit in the chair, right? Now, notice what we're doing here. We're sitting in a chair. It's exactly the same experiment as if we're in a rocket that's accelerated, sitting in a chair. And what that means is we are right now in an accelerated frame. All of you sitting in your, at home, you're in an accelerated frame. You're not in a frame at rest. You're in an accelerated frame.
Yeah.
And it turns out, let me think about this. Oh, we're all accelerating upward. Isn't that crazy?
How does that work?
So we're accelerating with respect to something.
I see. Okay.
It's all the inertial frames blowing by us right now. That's what we're accelerating with respect to. So that's the difference that you have to think about in the context of like expanding space-time and all that. Okay.
That is intriguing. I mean, so when you think about this stuff, do you think about it in terms of like a classical analogy like you just did, or is it just speak to you in the mathematics?
Both.
Okay.
Both.
You can see both.
Yeah. It sometimes the classical analogies don't work.
Yeah.
There's a common one on the YouTubes that just it frustrates me that people get it wrong. It's about electromagnetism. So people will often say magnetic fields are just electric particles being accelerated. and it's not quite right.
Yeah.
And it's because the reason it's not quite right is to really understand electromagnetism, you have to understand tensor calculus. It's people may be familiar with vector fields, but and then people think about electric fields as a vector field, or they think about a magnetic field as a vector field. It's actually not. It's a tensor field. And this is an example of like the reason people on YouTube get it wrong, and like all these popular people. Oh, what's his name? Veritasium. He has a famous one in which he says this, that basically magnetic fields are just electric fields accelerated. It's wrong. And it's because he doesn't understand tensor calculus.
Yeah.
And so anyway, that's an example of where our intuitive analogy can fail us sometimes, and you just have to develop a new intuition based upon the math.
I mean, so is it just flat out wrong, or it just misses a lot? Like, there's certain abstracts
Okay, it's
that
not
are good enough.
quite flat out wrong, but it does miss a lot. It misses. For example, if you took his analogy, light would not exist. you would say that, like, because light is an oscillation of electric field and magnetic field.
Yeah.
It wouldn't exist, because like if the magnetic field is just electric field accelerated, why is there the other component there?
Yeah.
There's no. In other words, what he's saying is, not accelerated, moving. I didn't mean accelerated, I meant moving. There is no frame you can go into that makes light disappear. And if you take, his results at face value, you could go to a different frame and make light disappear, but you can't.
Yeah. No, I mean, we have the same issue in quantum mechanics, right? At some point, your intuition no longer makes sense.
Yeah.
But one of my favorite analogies, like when talking about spin, it's like if you try to stick a USB drive in, you get it wrong, and then you flip it over, you get it wrong again, and then the third time it's right. That's quantum mechanics captured perfectly.
Yes.
It's a failure, but it's right.
Oh my gosh, that's awesome. All right, what is going on here?
Yeah, I don't know. Yeah, we'll give you some time with gaming.
Yeah. All right. Oh, I even have a clock here. It looks like I wasted 4 minutes on my clock.
Oh, this is chat's fault. Well, puppy, if I'm accelerating upwards, does that mean I can get enough height to join the NBA? It's not how this works.
All right, I think I need to think strategically in this one. I can't just like throw my forces at the bugs.
All right, here's a fun one. How long is the inevitable heat death of the universe? How much time do we have? And does Cuddle Puppy have to do their homework?
Yes, on the homework part.
Depends when your homework is due. Has that been defined?
Well, order of magnitude, yes. Yes, your homework is due.
Unless you're immortal, yes.
Yeah. Okay, yeah, so the heat death, I would say it's on the order of like billions of years, something like tens of billions of years. It's something like that. So you got time.
Well, Cuddle Puppy, my homework's due in 2.3 trillion years. You might be okay. Heat death of the universe. That's a fun one. All right, Reese's Pizza wants to know, could the universe be a manifold, something like a torus but with 3 space?
Oh, the universe is definitely a manifold. It is definitely a manifold. So let's define a manifold.
Yeah. Is this as simple as it can have edges? Is that...
Well, a manifold is basically it's a lower dimensional object in a higher dimensional space. Mm-hmm. That's what a manifold is, just plain and simple. And so, yeah, it's very possible that the universe is a manifold in general. And as far as we can tell, the universe is flat. We thought it was, it could have had like curvature to it, but it doesn't. It's flat. Now it's dynamic and expanding, but it's flat.
Your forces are under attack.
I'm wondering, is that
Not enough minerals.
enough, or were you wanting more to the manifold?
Reese's Pieces. I mean, let's assume not r to the third. I don't know what that is.
Yeah, talking about 3 space. Well, technically, the universe is minimum 4 space because of 3 space and time. And but there are credible theories that say that our universe has other important dimensions, and that our space is a subset of that, a projection, if you will, or a manifold.
You should not respond to this comment in any way, but Cuddle Puppy follows it up with, given how it's the 21st century, shouldn't we be using the gender neutral term personfold? Thank you, Cuddle Puppy. Always adding insights. Oh, man. Speaking of picking fights, A. Opal wants to know, this is one of our colleagues from the communications department, what are your opinions on George Santos? That's the Republican House member that lied his way into the election. Have you been...
I haven't been following that. Can you educate me on this?
I mean, he just lied, like chronically lied. He made up fake names, accounts, fake emails from like higher leaders up to raise money. He pretended he was Jewish and then pretended his parents died in 9/11. Like, there were well-documented chronic lying.
Yeah, that's weird.
But he won the election.
Yeah.
And he's still a...
Well, that's not too surprising. Right?
Mm-hmm. Yeah, no, that's an interesting case. Oh, man. Andy, you should probably work on a documentary on that one, because that is going to be a story of... Yep.
How's it going, Opal?
Matt isn't a robot. Basically treason, yes. I don't know if that one's treason, because it was not... I don't think he was trying to undermine the United States. He was just trying to, like, profit and, like, self-propagate. It's bad. You know,
in many circumstances, I mean, in some circumstances, it's illegal to lie, but in many, it's not illegal to lie. So, like, unfortunately, you can be a scumbag and not break laws.
Yep.
Like, we have a right to be scumbags.
That's the quote of the night, ladies and gentlemen. Maya Murphy, we have a right to be scumbags. Out of context, that's perfect. Oh, man, that's an intriguing one. But, Dr. Opal, he's in the communications. He does documentary filmmaking.
Yeah.
And so he's interested in science education and things like that, but also political opinions, obviously. So, he's a good person to know. He's working on, virtual reality documentary filmmaking.
Yeah.
Which... Astrophysics, there's probably going to be a lot of that with the images coming out of web.
We've talked about 3D imagery, things like that. There's a lot of data there. You know, there's a lot that we could do. It's a matter of time, finding the time to do all your pet projects.
Oh, exactly. So many ideas and not enough time to pursue them. Because all the bureaucracy we have to deal with. But that is a separate rant entirely. All right. Raining Comets wants to know, does more time pass the faster you travel in space?
So that's time dilation. So, and it actually is the opposite. Well, moving clocks appear to tick slowly. Moving clocks appear to tick slowly. So this is one of the very funny things about, like, okay, so let's go back to the statement about the speed of light being constant. That's one of the postulates of relativity. It has very funky ramifications, and one of them is time and space are not constant, but that's one of the things that are relative. It depends upon what frame you're in, like how fast you're moving relative to the other frame, what you see. So things that are moving fast, their clocks appear to be ticking slowly. You won't agree on time. You just won't agree on time. You don't even agree on what's happening at the same time. You can set up things to happen at the same time, and then someone who's going by will blow by and go, no, those aren't happening at the same time. This one over here is happening first, then that one, then that one, and then that one. Which has a lot of interesting ramifications for time and order of events and free will even. I don't know if I really go down that rabbit hole myself, but it is interesting to think about. The other time that you have time dilation is when you're looking at things that are deep in gravity. So, for example, even here on Earth, you know, we all have is it going to pick up my cell phone, or is it going to green screen it out? Oh, yeah, you got it. So, even the cell phones, like, you know, these are accurate timepieces and they communicate with satellites in space. Well, they're farther from Earth, so they're higher up in gravity. And so time is progressing differently for our phone down here versus the satellites. And they have to take that into account to be able to make even the position that this thing does very accurately. Because that's how it does it. What it does is send signals back and forth and measures the time difference. And that's... yeah, but if you didn't account for relativity and this fact of time dilation, even in gravity, then you wouldn't get it. You wouldn't get it right.
Yeah, I think one of the fun examples, you can correct me if I'm wrong, but GPS would not work.
Yeah,
unless
exactly.
You did relativity corrections.
Yeah. GPS would not work.
Which is
without
amazing
relativity,
because,
yeah.
like, that's Einstein 115 years ago.
Yeah,
predicted GPS would not work.
Yeah, exactly.
Without
Yeah,
relativity, which is absolutely amazing.
Yeah, the story as I hear it is when they were developing GPS way back when, they had a hard switch in there that was like, well, you know, we don't know if the relativity is completely right yet, so we're going to include the calculation, and if it's not right, we'll turn it off. So it turns out they had to include it.
Just that little fudge factor.
Yeah.
You know. Just multiply by a constant, it'll be fine. That's amazing. But there was a real experiment on this. There was a set of twins where one was an astronaut, went to space. Right?
Yeah. One of them is married to Gabby Gifford, who was shot.
Oh yeah.
Yeah, she was an Arizona congressperson or senator.
I think she was senator.
Yeah. Anyway, I forget their name. Yeah, they did this. It turns I did the calculation of like what was the time difference between the.
Because it was like 200 days or something.
Yeah,
right?
they were there for a year. The main experiment they were doing is like, it's a terrible experiment. When the other twin comes back, how do they compare in terms of physiology to the twin that stayed home?
I don't think time dilation was the main impact.
No, it wasn't.
Right?
The age difference was 1 second after a year.
Man, you look 1 second older. Like, look at all those white hairs. But I mean, like the 0G and the bone density and all the other stuff.
That's what they were really testing is like really serious
so
damage.
time dilation did not matter.
Yeah, no.
You did the math, which is amazing.
Yeah.
That's really fun.
Yeah, actually, so for things in orbit, right? For things to stay in orbit, they have to go really fast. Something on the order of 9 kilometers per second to be in low Earth orbit. Mm-hmm. It has to go really fast. Remember, I said you get time dilation with fast, and you get time dilation just being at different heights away from the center of gravity. So in lower gravity. And I did the two calculations because it wasn't clear which one was going to win out. Mm-hmm. But yeah, I don't remember which one. I'd have to think about it a little bit. But yeah, they're basically avoided the same effect. They're going fast, and it's called gravitational time dilation or redshift. Oh yeah, there you go.
Look up the name. It's Mark Kelly. I know
Mark
that's
Kelly,
one
yeah.
of the two. Or
Yeah, Kelly.
Mark. There they are. Well, one's got a mustache.
Yeah.
How did gravity account for that one? There you go. There's the difference, ladies.
Oh, right.
Sorry. Oh, you don't look a second over 43.000000002 years old.
I think I'm gonna end up losing this one. There's a time thing that's happening.
You have no idea what's going on.
I need to look at the mission objective. Survive for 30 minutes. Okay, they're gonna send a force to try to obliterate me at some point. I'm sure. Probably like at 10 minutes. So I better build up my troops just to protect myself. Looks like I'm gonna need some turrets to protect. Let's see.
All right, Matt isn't a robot. Welcome to the stream. Thank you for joining us. Thank you for the question. Matt wants to know, could we use quantum entanglements to better communicate time?
To better communicate time?
And so theoretically, quantum information separated by a distance that's faster than light, right?
That's the idea. Okay,
yeah.
Okay. I don't know. I haven't thought about that one. You know, that's not a crazy idea. Yeah, because I'm like, Okay, now I'm thinking all sorts of things like, okay, so I just said a moment ago, simultaneity is a problem. And I was just thinking, oh yeah, you could use quantum entanglement to synchronize things, but wait, that's a problem.
But you can't know, right?
Yeah, so... All right, so the way quantum entanglement works is you prepare something, you don't look at it, you prepare two things that are entangled, then you separate them, and then when you look at one, you know its state, and you immediately know the state of the other. Could that help you with time? Like, I'm wondering, because, like, right, atomic clocks, that's basically what they do. They're using the quantum decay, they're using the decay rate of some radioactive thing.
Yeah. I don't know how that works, because even if you know what's happening at the other place, you can't communicate. Like, I don't know. It's beyond me.
Yeah, that's a good point.
Like, you know information that's been introduced, but you don't know the value of that information.
Yeah.
Right?
Oh, here we
One
go.
or zero.
Ladies and gentlemen, I think you're about to watch me die.
That's fine. Talking science. We'll let Maya focus on the game a little bit. Throw your questions in chat. Anyone just joining us, Ask a Scientist Gaming, mediocre gameplay, expert science, especially tonight. But our guest today is Dr. Maya Murphy, who's an astrophysicist who studies, he models supernova and the explosion and subsequent black hole formation, doing a lot of computations theory, modeling, describing space and what happens in space, but also teaches introductory astrophysics and is happy to talk about relativity and whatever you guys might be interested in. Cuddle Puppy, calling this mediocre gameplay is an insult to mediocre. Shots fired. Take that, Maya. What did you learn being a guest on this stream?
Well, let's I did warn people I'm not very good at multitasking, so when I'm talking, my hands are up here.
Yeah.
They're not playing a game.
And people don't appreciate how hard this is.
Yeah.
So like watching Twitch, I'm watching like these really high level players.
Oh, yeah. How can they? Yeah. How can they do that at the same time?
And in this case, I'm feeding you the questions. You don't have to read.
Yeah,
them.
I don't have.
They're doing it. Wow.
Exactly. Yeah.
It's absolutely amazing.
Yeah. Well, okay. Now we know I'm not making my millions on Twitch.
But that's so the reason I started this stream, or one of the reasons, I thought of this before COVID happened, actually. Like, I was thinking of this idea of moving into Twitch, because the thing I noticed is the people that give viewers is not the best game players. It's the most interesting people.
Yeah.
Right? Because it's a radio show.
Yeah. That's right. Yeah.
It's like the games are just background.
Yeah.
So
yep.
As long as your topic's interesting, people will watch. That means you, Cuddle Puppy. You come back regularly for this shit.
Oh,
but anyway, so I'll give you an easier one. We don't have to think about quantum entanglements, signal processing. 6-year-old Maya Murphy was probably not like, I'm going to be an astrophysicist and a professor at FSU. So what was your journey? What was your major turning points?
Oh, okay. So when I was young, I was curious about the universe. I was curious about space, and so I was just curious. And it also was obvious that I had, the kind of scientific thinking mind, and that I love solving problems. I was very curious. I wanted to understand things. And but I had no idea what I wanted to do, and even that it would be a possibility to do astrophysics. So then when I went into high school, I was like, okay, like, who is an astrophysics professor? Like, that's not even a job.
You just made that up.
Yeah. So I was like, okay, I'll be an aeronautical engineer. I'll build spacecraft. I'll build airplanes and things like that. And then when I was I went to University of Washington for my undergraduate, and I was an aeronautical engineer major to begin with. And then I took my first physics class, and that really, it really resonated with me, that way of thinking, that way of understanding the universe, and just asking big questions and trying to find answers.
So this was calc-based Newtonian physics?
Yeah, exactly. Those first introductory calculus classes that engineers have to take. And I loved it. I loved my experience. And then I took an astronomy course. It was Astronomy 101, actually.
Pause.
And
Cuddle Puppy said, build bunkers.
Yes, thank you.
Try to coach you. Sorry, we'll get back.
Yeah, you're right. I probably should build a bunker or two. You're absolutely right. I've been looking at this and I'm like, oh man, my Marines, they're dying. Poor guys.
I love that there are people watching this right now that can't hear anything you say because they're like, he's doing it wrong. Just like raging at your gameplay. Build bunkers, damn it. Who gives a shit about your childhood? Thank you, Cuddle Puppy. Your insights are appreciated.
Yeah. All right, let me steal this guy. I'll build another bunker over here. Yeah, usually what I do is I just build bunkers over here, and then I survive the oncoming wrath, and I put turrets over here.
Y'all should play Alien Isolation.
Why is it not building?
Alien Isolation on stream. I have not seen this before. I will have to take a look at that. Matt, thank you for the suggestion.
All right.
All right, you're building bunkers. Sorry, you took your first physics class. It resonated with you. There was something about it that spoke.
Yeah, and then astronomy, same thing happened. It really resonated with me, and so I decided to switch my major. Yeah, and yeah, so then I switched my major to physics and astronomy. Okay, then what's my path from there? You know, when you're doing academia, it's never clear that you're going to stay in academia.
Yeah.
You're always like, there's a fog at the end of like undergraduate. You're like, okay, I graduated, or I'm going to graduate in a year. If I want to go to grad school, I need to apply, but you have no idea if you're going to get in.
Mm-hmm.
You think you do, but you don't know.
Yeah.
So I did that. I went to University of Arizona for astronomy degree. I did that in my field in supernovae. And then from there, I got an NSF postdoctoral fellowship. So that's a fellowship that, so after you get your PhD, you do postdocs, which are like temporary 3-year positions. And in my field, you usually do like 2 of those before you're seriously considered for being professor somewhere.
It's like professor training,
Yeah.
no classes, but more
Yeah.
responsibility kind of thing.
Yeah. And then, I'm really... Thank you for... who was that? Cuddle Puppy told me to build some bunkers.
Yep.
There's some bunkers over here with no one in them. Those aren't helpful.
It's just like building bunkers was not enough.
All right, let's repair this guy.
So at some point, oh, there you go. So at some point, you committed to the academic route. You said, "I want to do this. I'm going to apply for professor positions."
Yeah, things were going well for me. And then after the postdoc NSF fellowship, I went. My next postdoc was at Princeton. That was a lot of fun, intellectually stimulating, and New York was nearby.
Mm-hmm.
And then I came here. I was offered the job here, and it was very intriguing. And I took it, and so I've been here and still doing astrophysics.
Yeah, we both started 2013, right?
Yeah.
We're almost a decade in.
Yeah.
Isn't that crazy?
Yeah, I know.
Time flies when you're having fun.
Yeah.
But I mean, that's so there aren't a lot of professional astrophysicists. There's not astrophysics industry jobs, right? If I'm not mistaken, there a lot of people go into like economics, right? And like obscure, like non-related things.
Yeah, so basically we're trained to solve problems, and we do a lot of software engineering to solve those problems.
Mm-hmm.
And so those are appealing skills to have in the industry. And so I have a lot of friends who are in a lot of software companies, like Google, Microsoft, Spotify, you name it, things like that. Microsoft, probably already said that.
No worries.
So there's that. Yes, economics. There is. Here we go. Please repair that. Do that. And I think that's pretty much the story.
That's your journey. All right, a follow-up question I like to ask: what was your I made it moment? Especially as an assistant professor, we're so insecure and we have imposter syndrome. But there's
Lord.
do you have that moment?
When I got tenure?
That's a big one.
Yeah. Well, actually, seriously, there was a lot of just like completely different mindset. I have found I'm able to think about the big picture more often now, and I'm enjoying it a lot more. For example,
Forces are under
we just developed a new software to figure out which stars explode, like that, what I was talking about earlier in terms of. Sorry, I'm about to die,
Yeah,
so I'm a little distracted now.
you're fighting the good fight.
Yeah. And I really did not do any development here. Like, I mean, look, I'm supposed to like increase my Marines' firepower over here.
In your defense, you did start 4 minutes behind. Like you just like, I'm gonna handicap myself.
Yeah, that's. I mean, look at this. It's a very good chance I'm gonna die. This is not looking good. I'm like level 2 in StarCraft. Yeah.
No worries. It was worth the journey.
All right.
But yeah, if anyone has questions for Dr. Jeremiah Murphy while he gets absolutely destroyed in StarCraft, this is an opportune time for him to answer.
About
any
really
discussion.
dumb AI.
But that was it. The 10-year decision. I mean, was there a paper that came out that was your, like,
Yeah,
baby?
so there's some papers like recently that have come out that are really fun for us. So I said that we use supercomputers to figure out how they're exploding. So in general, we've done that because it's a really complicated process, and you think like you just need the supercomputer to calculate it. But it turns out that a graduate student and I were able to develop what we call analytic calculations, or basically like math you can write down on pen and paper that describes when these stars explode. And so we developed this theory. So like developing theory, and now we're gonna start testing it.
Fuck. What?
I think it's because I survived like one.
Oh, the 30 minutes.
Yeah, I survived 30 minutes.
You walked away. Oh
I
man.
literally just I was like, I'm dead. I'm not doing it anymore.
We weren't even watching the action. You won.
Oh Lord.
Man. Too easy.
Yeah.
Do you want to keep going? Do you want to try Quake? Do you want to move to something else? It is. Matt isn't a robot. Life finds a way. It
Yeah.
did. It absolutely did. Holy shit.
What was I even saying? Oh yeah. So we developed this theory on how, I'm predicting which stars will explode, and so now what we're going to do is we're going to use the simulations to test elements of our theory.
Oh, that's fun.
Yeah. So, and I like that. Like that, I'm a theorist. I like that. Like getting down to the essentials of science, in which you have a theory, you make a prediction, and then you test the prediction. Because the worst thing you can do in science is make postdictions. You have observations. You're like, oh, I can predict that after the fact. But it's really fun to make a prediction ahead of the time. And so, yeah, that paper, it came out. We've been testing it, and it survived all the tests so far.
That's awesome.
So that's been fun. That's been fun.
I mean, what's going to be fun is when it fails and why, right?
Yeah.
Because like, there's the gap.
Yeah,
right?
yeah, yep, yep. There's actually a paper I'm working on right now. It's top secret. That's a lot of fun. Yeah.
Share it on Twitch.
Yeah, we may have discovered something about a nearby star that exploded. That's like something we've long suspected in the community, but we just haven't found the data yet. And I've been working on a new project to do that. So, sorry I can't announce it right now.
Yeah.
But yeah, that would be fun.
The Mahern, your lectures are dope. Keep showing more pics of telescope stuff. It's fire.
Thanks.
That's awesome.
I appreciate that.
You need to go to Rate My Professor, copy and paste that exact sentence. Do you look at your Rate My Professor?
I don't.
Should we look at it?
No. I don't. I looked at it in the first couple of years. I was like, oh, really?
Yeah.
So here's the thing: is that those kinds of, even like the evaluations you get, I will get
right.
things
Yeah.
like, look, I get high ratings on my evaluations, but I will get things where like people will say you're the best professor I've ever had, and then the next one will be you're the worst professor I've ever had. Which one of those is true?
So I
Neither one.
I should send you my syllabus day lecture because I'm like going through the syllabus, but I'm like, what is Ken like as a professor? And I literally have a pros and cons like from my previous reviews that are matched up like that. Like it's not plug and chug. It's not plug and chug. He talks too fast. He talks fast and is entertaining. Like it's just
Yeah.
and it's all perception based.
Yeah.
Cuddle Puppy, you're the worst bunker builder I've ever heard of. Also add that to his rate. We're gonna. Oh man, we're attacking you, rate my professor.
Okay. Definitely put that in Rate My Professor. Worst bunker builder ever.
Give him 1. No chili peppers for you. They got rid of him. All right. The proper response was, but you have heard of me. Absolutely. All right. What do you want to do? What game? Do you want to keep playing?
Let's
do
see.
Something else.
Let's dive into Quake.
Okay.
I played that a little bit.
Let's give Quake a try.
It may be really boring.
Yeah.
Yeah. Escape possibly?
Escape.
Okay. Oh, well. Just keep doing that.
Yep.
Keep
And
going.
then exit. And then Quake should be down here. All right. And then you should be able to resume game.
Yay. Look, there it is. All right. So there is a really cool fact about Quake that as a programmer.
Somebody request a factoid.
Oh, there you go.
Maya's ready to deliver. Don't give this out for free.
Oh.
They need to spend their internet points. Let me see. There's cheat codes for game. You want to start a new
Are you
game?
sure? Yes.
Yes. Why?
Yeah, why? Okay. Okay. If anyone remembers how, like, what the point of Quake is besides shooting things, I'll go into easy. Oh, I think I remember you could build your own worlds. They made, when this game came out, they made something where you could build your own worlds.
Oh,
So, is A Opal still on?
that's a good question, Andy. If you're on, this would be a fun discussion point.
Oh,
Trying to find a God mode cheat code for you here. So press tilde.
whoa. Like shift tilde?
I think just, and then press God, or just type in God. See if it gives you
God mode on.
All right, now we're good.
So what is this like?
Infinite bullets, all health.
Okay.
You have
All
nothing
right.
to worry
So
about.
I can just run.
Yep. Yeah, no sleep lost here. Video game purist, avert your eyes. That's how we roll on Ask a Scientist Gaming.
Wait. What's going on? I'm supposed to be able to look up and down, right?
I don't know if you can in this one.
Oh,
'Cause
okay.
I think it shoots up when you aim towards them.
Oh, okay.
Like it auto. But somebody can correct us if I'm wrong. I didn't play a lot of Quake. I did Wolfenstein and Doom.
And Doom?
And then Halo was my my bread and butter. I played a lot of Halo.
Oh, how do you strafe?
Quake.
Yeah. Oh, well. It doesn't matter. You need the gold key card. All right, here we go. First quest.
Here, I'll look up some Quake controls. When was the last time you played Quake?
Oh, Lord.
Note that it is 2023.
Yeah. Let's see. I was an undergraduate from 96 to 2001. That's about the time Quake was out.
Mm-hmm.
That's probably when I last played.
All right. Step left, step right. Period and comma.
Really?
Ooh, yeah.
That's too far away.
Yep, there it is.
What? That's
we
silly.
could map it to something else if you want.
I wonder what I mapped it to before.
Because you did the AWSD.
Yeah.
All right, back to the science. The Mahern, who's a student in your class, by the way, do you have any helpful tricks for the NCP, SCP, and latitude stuff from today? Well, let's start with what's NCP, SCP, and latitude stuff.
Yeah, so NCP stands for North Celestial Pole, SCP South Celestial Pole, and latitude stuff. So I think I'm gonna need more context if you want helpful tricks with that. You know what? That's a lot of like trying to get your mind around kind of the geometry of Earth in orbit and doing. Oh, there's a gold key card. Look at that. And so doing a lot of mental modeling of the Earth and the horizon and things like that will help with that.
That's interesting. So just a mental frame of reference.
Yeah.
I mean, how easy would all that be if the Earth wasn't tilted 23 degrees? Like, that's what
there would a lot,
all of it, right?
Yeah, right. There would be more. Yeah, it would be easier for sure. Also, well, I mean, good grief! Like we're orbiting a star.
That's true, and it's not it's elliptical and not spherical, and space is hard.
Where was I?
Galileo.
Okay, doesn't that look like a gold key card?
Let's see the weird anomalies of space motion. So people talk about Mercury in retrograde as if it's some infecting your life phenomena, but like
what is that?
Perceptually, that is a weird thing.
Yeah.
Right? Like, can you explain that?
Well, so what that is hey.
Because it's all ellipses around the sun, but it doesn't. It's a perception from us.
So Mars, the retrograde one, it's the most striking one. So so for much of the year, it appears Mars is going in one direction across the sky, and then it appears to go backwards across the sky. And it took a while for people to figure out what's going on. But basically, what's happening is, you imagine you got the sun, you got Mercury orbiting it, then you got Venus, then you have Earth, and you have Mars. Well, we're all orbiting it. The inner planets are actually orbiting faster than the outer ones. So while we're on the other side looking at Mars, it appears to go in the normal direction. Mm-hmm. But once you get close to Mars and we're passing it, it's like you're passing a car. It looks like the car is going backwards, but, from one perspective, all of you are going down the same, direction on the freeway. So it's really just a perspective thing on why it appears things go in that retrograde motion.
I mean, so that was... Oh, go ahead.
I was going to say, and it was Copernicus who really helped us to understand, okay, now we see why Jeremiah is really bad at multitasking. I'm trying to find... Oh, there it is.
And I was going to say, that was one of the really early... I mean, you love physics, well, sciences in general, because it's like, we have a model. This doesn't make sense with that model.
Yeah.
So the Earth obviously can't be the center of the solar system.
Yep, exactly.
That shit's going backwards, and that doesn't make sense.
Yeah.
So, shout out to Copernicus. Was later... Is he the one that was post-mortem accepted by the Catholic Church as being acceptable? Galileo was.
That was Galileo, yeah. Galileo was... he basically said, yes, Copernicus is right.
All right, we should do one of our predictions. You did all the effort to make these guys. Which one do you want to go with? What do you want to talk about? Let's go with that.
I am about to drown.
Survive out of the water. Can you drown in God mode?
That's a good point. Okay, let me just back up here.
All right.
Back up, protect myself.
We'll move the bourbon so you can see the science questions. New sentence uttered for the first time tonight.
Okay, let's go with the top one.
Okay. All right, so there are black holes at the center of galaxies.
Yep,
every galaxy. Center of all of them. That's always true.
Yeah, there's a black hole at the center of all galaxies as far as we can tell.
All right, so that'll give you some context into this question. Okay, so those of you not familiar, we do predictions on this channel. They're science questions. You can ask them and have fun answering, right or wrong. It's up to you to guess how you want to. But basically, we're going to use imaginary internet points that are specific to this channel, and you can gamble how confident you are on the question. So, I'll put up a prediction right now. You'll have 2 minutes to answer this question. Click the predict button, gamble your points accordingly. Again, it doesn't matter what you do with these, but have fun. It's a pride-based thing, really. But the question is, there are black holes at the center of all galaxies. Does that dictate star orbit? Or that does dictate star orbit, true or false?
And what we mean by that is, so there's a black hole at the center of all galaxies. Do the black holes dictate the orbits of all the stars in the galaxy?
That's fun. This is stuff I don't think about. Like that is a large question.
This is actually inspired by a question that a student asked in class.
Today or recently?
Recently, like last week.
That's pretty fun.
Yeah, it was like, oh, that's an interesting perspective that you had.
Shout out to the students. So,
yeah.
Does the black hole at the center of galaxies, the supermassive black holes, does it dictate star orbits? Is this exclusively dictate or part of the dictation? Is that?
It doesn't matter either way.
All right.
The answer's the same.
That might have given away a hint. I apologize if I ruined the question with that.
Okay. You know, this is one of the things I do remember about Quake was, yeah, these first-person shooters got better because in the beginning, it was mostly just running around a maze.
Yeah.
And, like, okay, so there's...
No, I agree. Like, Halo was one of the first ones where it was a very intuitive path. It was still a pseudo-open world, but it gave you directionality.
Yeah.
I agree.
Oh, this is... Oh, here we go. Oh, this is back where I came from. I don't know. All right, this one may be a flop.
Let me see if I can find a Quake map. So you're on the second level?
I don't even know.
Quake.
I need to get over there, it looks like. There's people I have not killed over there yet. So that means I need to get over there. So let's see. All right. I can't... Oh, there we go. There we go.
Single player maps.
I think I found it. Finally. Oh, maybe not. I just came from here. Oh, this is an elevator. That's it. Finally.
No worries.
There is there's like the whole... I used to use this mode a lot on these games.
Oh, the strafe.
Yeah, it's annoying that it's way over there.
Yeah.
Whatever.
All right. Black holes at the galaxy center dictate star orbits. True or false? Maya, what is the answer?
False.
False. Everyone said false.
Oh, that's cool.
Everyone knew the answer. I hope they're your students. If not, congratulations, everyone. You got 0 internet points because no one bet against you.
Oh.
Pride was on the line.
All right, so that was my fault for putting one that was not that difficult.
But it's weird because it's like this is another one.
So
would he ask if it wasn't?
Yeah. So here's the misconception that often happens is like, so people think that black holes they just suck everything in, right? That's what they think of black holes, is like extreme gravity and they suck everything in, but they don't. They just have gravity like everything else. And it turns out supermassive black holes, while they are very massive, they're a small fraction of the mass of a galaxy. And so most of the mass of the galaxy is in the inner parts, it's actually in stars and gas. But when you look at the galaxy overall, most of the mass is in dark matter. And so that's what dictates the gravity, and hence that's what dictates the orbits of the stars in the galaxy. It's not the black hole.
That's pretty fun.
Yeah, but a student was like, oh, so since there's a black hole at the center of every galaxy, does that mean that they dictate the orbits of the stars in the galaxy? I was like, oh, I see where you're going with that, but no, that's not.
It's translating the solar system to a black hole.
Yeah, exactly.
Yeah. It's one where your intuition fails, and it's dark matter that screws all that up.
Yep. Yeah.
I saw a recent popular science news story that said something like there are too many black holes in the early universe or something like that.
Yeah. So that's part of what JBST will help solve. So the problem is what I just said. So there's a supermassive black hole in the center of every galaxy.
Yep.
All right. So the way galaxies form is basically Legos. You start out with small stuff. Small stuff collapses from gas and clouds, and then those small things merge together and make bigger things. And so that's how you get the large galaxies today. Is like smaller galaxies merge over time. So, and presumably the black holes are going along for a ride in this. You know, you merge two galaxies, each of them has a black hole, and the black holes are going to have to merge, so you build bigger black holes. Well, the problem with this story is that we can see, you know, the farther you look, the further back in time you're looking, and we can see galaxies that have very large black holes, like 10 to the 9 times the mass of the sun. And the question is, like, how do you build up a black hole so massive so early on? You're actually pushing the limits of like how we think black holes form, which is there's two ways. One, they merge. Another is, oh, good thing I have God mode on. I'm just gonna kill you like this. The other way is they just when gas and dust gets close to them, they form this accretion disk, and once it does get close, then stuff falls onto the black hole and accretes and builds up mass that way. But like going back to this, there are too many black holes early in the universe. How do you build up those black holes? One idea is that for some reason in the beginning of the universe, there were large clumps of matter that collapsed and immediately formed a seed of a large black hole, and then they were able to basically accrete more material and grow from there. So that's one idea.
So this is a recent theory. What does recent mean in this? The last 10 years or so?
No, a little older than that. Maybe 20.
And so Webb will test this.
Yeah.
Like somebody has a model.
Yeah, because Webb is designed to see the first things that formed. We might be able to see like the formation of these first black holes. It's definitely a might, but it's a hope.
Yeah.
I would be really excited. Like I'm hopeful that James Webb will be able to see. We'll be able to provide some sort of answer to that.
All right. Reese's Pieces has redeemed Take a Drink. So Maya, let's keep drinking. Cheers. Reese's Pieces. Thank you everyone else for joining us. Cheers. Wednesday night, talking science, playing a little bit of Quake, astrophysics, space stuff. If you guys have questions, throw them in chat. I'm going to run to the restroom, but I'm going to leave you with a question.
Okay.
Let's say, here's an open-ended fun one that'll give you a couple minutes. If you can completely change your research, like completely restart grad school or change disciplines entirely. I mean, we're talking art history, political science, you know, whatever you want to do. What intrigues you? Where would you go?
Yeah. I've been very intrigued by emotional intelligence recently. I don't know if I would change. Like I really like what I do. It's a really cool job. Get to ask profound questions about the universe and inspire the next generation. But I really am appreciating emotional intelligence and having greater awareness in my own life. I've gained a lot more calmness in my life in working in that. And there's just a lot to learn there. And I've been intrigued by that. I've also been intrigued by how our society values like the kind of science that I do, which is based upon problem solving. That's one type of intelligence, is problem solving. But another type of intelligence is emotional intelligence. Yet we don't teach that regularly within like public school systems or like even academic institutions. I mean, you can certainly take psychology courses or go to social work or, you know, take those kinds of courses, which you would learn a great deal of emotional intelligence. But it's not like a foundational principle that every student has to take when they go to school. So that's, yeah. And I'm seeing progress in that field that's really intriguing. So, yeah. So that's what... I don't know if you heard any of that.
No, I did not.
Yeah.
The short answer is arborist.
I'm intrigued with emotional intelligence.
Oh, yeah, that's the human component.
Yeah, exactly. And what I was just basically saying is that I've learned a lot recently, and it's really added a lot of calmness and awareness in my life. And it's something that I'm seeing. Like, I really think we should be advocating for like the school system to be teaching emotional intelligence from the very beginning, just like basic stuff, even like, what are you feeling? even just noting what you're feeling actually does a lot for you in terms of awareness, and like what is it you need, and like somehow we haven't valued that.
I mean, I think they're getting much more thoughtful about that, right? Like there's conscientious discipline and reflective. I think it's a slow process, obviously, changing anything that big. But even looking at our kids going to school and stuff, and deciding between charter and public, and I don't know, we've been pretty happy so far.
Yeah. You know what? I think Quake is a bust.
You're good.
I'm just running around.
I have no idea. All right.
Let's move on to another game.
All right.
What were the other games that we had?
We got the Nintendo. Do you want to do some battle chess?
Sure, let's try it.
All right, let's do some battle
that may
chess.
be equally boring. We'll try it.
I mean, we'll give it a try. We're going to bump forward in time.
Battle chess.
Yeah. It's just chess on the Nintendo system. Are you ready for this? All right. You ready for some 8-bit action?
Yeah. I'm
You try the mouse and keyboard. You are not ready for this.
Can we show what I'm at? Yeah, look at this.
It's the original Nintendo. That's the actual original hardware. I have a Nintendo USB converter. So that is a 1986.
I will be gentle.
No,
I won't be button mashing on this chess battle.
I literally have a bucket back there with 20 of them.
Oh, okay.
So you saw the collection. we could do Power Glove battle chess if you really want.
All right, I'm guessing I press start. Yeah. Oh, there we go.
All right.
Whoa, I can't even see the pieces. What is going on? Okay, this is, I presume I'm white.
You can see it up there.
Yeah, I presume I'm white. This is the king, this is the queen. All right, well, we're just going to move e4. Okay, how does this work?
There we go, ladies and gentlemen.
Boom.
This is battle chess for the Nintendo Entertainment
Oh my
System.
gosh. As if chess isn't slow enough. The pieces actually take their time to walk forward.
Oh, there's animations for the battle.
Oh, right.
Steve Leonard played this. So this is on the easiest level. Apparently, you can change the difficulty levels.
Okay, all right.
It takes a really long time to actually compute on the highest level.
Let's just do some standard play. All right. So we're moving our knight over. Once I move these pieces, oh my gosh, the pawn has to get out of the way so the knight can move.
No. So there's different subcategories on Twitch. So we switch between science and technology and just chatting. I'm gonna put us in the chess subreddit. The chess Twitch stream.
Okay.
And this is where all the big dogs show up. It's really popular on Twitch actually.
Chess. Mm-hmm. Yeah. Yeah, I imagine. Oh my gosh, this is going to take forever just because these pieces take forever to move.
No worries. We're not in a hurry.
This is going to be hilarious.
Who's the big dog now? It's the Magnuson. What is his name? Magnus Carlsen.
Yeah, Magnus Carlsen, yeah.
He streams on Twitch. So we'll bring our Ask a Scientist gaming level of battle chess on the NES.
This is actually going to present a challenge because you're used to seeing the pieces in the board in a certain way, but it's really hard to tell what these pieces are.
Yeah.
Once they start developing, I may hang some pieces here. Just because I'm like, oh, that was a queen.
No worries.
You can actually move in that direction.
No worries. All right, anyone just joining us, Ask Scientist Gaming, mediocre gameplay, expert science. We have transitioned to battle chess for the Nintendo Entertainment System, but our guest today is Dr. Maya Murphy, who is an expert in astrophysics, all things physics. Throw your questions in chat. He's happy to answer them while playing chess. I mean, thankfully, this one is less involved.
Yeah,
right?
Exactly,
You get breaks.
Yeah, and also, it's so slow. Just, this is a standard opening in chess. Oh, look at that. The king is going to castle.
Yep.
Good job.
My favorite part is that the building gets up and walks.
Yeah. All right.
game's captures reality really well.
Yeah.
All right, so I got a fun question that I ask everyone. What's your favorite equation?
Oh, that's easy. The Einstein field equations. There's essentially two fundamental theories in physics. One is quantum physics, and the other one is Einstein's field equations. So one is quantum physics, and the other one is general relativity. So the stuff that leads to black holes. It is such, in my mind, like an elegant culmination of advanced mathematics that needed to be developed to help to explain what Einstein was thinking in his brain in terms of the physics. Yeah, that's it.
All right. That's relevant to your research, or that's just elegance
Lord.
you love?
Both. Both. Yeah, this is... Okay, I think that's a night.
That is a knight.
That's a night, and that's a night.
That's knight, yep.
Okay.
And then you have your knights
So,
out.
yeah. So, okay, this is a pawn. That's a bishop. It's gonna be hard just to see.
No worries. There's no pressure.
Oh yeah. No, I'm. Let's see. We're gonna have to do something unique here, I think. Somehow. You know what? I think I want to. Let's develop.
Let's pin a queen. Oh no. You're going that way.
Yeah.
I like it. Do you remember the early computerized games? Like they had magnets underneath them and they would move pieces and stuff. Man, I was really into chess for a long time, and then Deep Blue beat Kasparov, and I was like, I'm done. I'm done.
Well, that's actually something that's fun that's happened with chess is, once that happened, I thought chess was going to die. All right, computers are beating humans now, but it's gotten to the point where, something fascinating has developed. The computers are so good that they almost go beyond theory now, and they do these weird moves that are inhuman.
Yeah.
And it's different. It doesn't even look the same as two really good humans playing.
Yeah.
So for example, I can fall I definitely cannot, I'm nowhere near these master level people, but I can follow along what they're doing. I understand the theory of what they're doing. Mm-hmm. But sometimes with a computer, you're like, why'd you do that?
Yeah.
Oh, it's in 20 moves, you realize it's a much better position.
Yep.
Yeah, so it's just a different way of playing, and I'm wondering if humans are gonna learn that, figure that out at some point. I don't know.
Well, I love
maybe not.
I love the political social implications of that, because it was when Kasparov got beat by Deep Blue, he accused someone of cheating, right? And he was like, it wasn't moving like a computer should. He knew what a computer should do. But that also happened recently too, right? With the Carlson and the butt plug accusations, right?
Yeah.
It's not doing what a human should. It's doing what a computer might do.
Yeah, exactly. Yeah.
That's
actually there was
meta.
a recent statistical analysis on that guy. What's Hans Niemann?
Yep.
Very interesting statistical analysis. Basically, what they did is what you can do is you can see what's a human's correlation with the way a computer plays. Mm-hmm. Even the best players rarely get to very rarely in their entire life, maybe once 100% correlation with the way a computer plays. This guy who's been accused of cheating has had his games correlate with how computers play 10 times. So maybe
Maybe
might
a
be
red
cheating.
flag.
Yeah.
I just love the butt plug accusation, because it's you had to practice that. You had to troubleshoot communication. I get it.
Yeah.
High level performance. Forget roid doping. Let's do computerized gameplay.
You know what? Let's go ahead. Is this how I castle?
Yep, king first. Yep.
Yeah. Okay.
It's intriguing. But all right, anyone just joining us, from the chess Twitch channels. We're Ask a Scientist Gaming, mediocre gameplay, expert science. Maya Murphy is playing BattleChess for the Nintendo Entertainment System, which is very slow but animated and, I don't know, vibrant gameplay of chess.
Yeah.
But he's also an expert in astrophysics. So if you have any questions about space, about James Webb Telescope, about the fusion reaction or nuclear reactions or anything of that nature, please feel free to throw your questions in chat. We're happy to answer them. Okay. You guys should have a friend give you scientific answers through a butt plug. Oh,
Okay.
yeah.
Oh,
No,
man.
That falls under the Ask a Scientist fans only. So, no, that's...
Oh, man. Did someone just invent a way for students to cheat? I'm sure it's been done.
I mean,
I'm sure
yeah.
it's been done. Okay. I don't even know. Okay, so this is a knight.
You know, at some point as a professor, I'm like, you earned it. You earned that cheat. I can't even.
Yeah.
Did Ken just tease and Ask a Scientist only fans? That's the next iteration. I just love that accusation existed. They're like, how could he have cheated? I know. This is the answer of all the possible ways. That is the one. Oh my god.
Oh my gosh, it's actually so hard to see this board. I think that's a bishop.
Has anyone died yet? Or you taking
No.
anyone?
I haven't taken
Oh,
anyone
man.
yet.
That's
No.
fun.
Yeah, everyone's. Oh, really? Okay. Well, maybe I should just do it.
Well, no, dude, strategically, I don't want to pressure you.
No, it's okay. I have zero attachment to this game.
For the audience, for the fans. But yeah, if you guys have physics questions, Maya's very happy to answer those. If not, I have a bunch of my standard questions. All right, we'll go with one of those. So one we like to ask, and maybe the answer is one of these questions. What is the flat Earth or anti-vax equivalent of your field? I mean, is it literally flat Earth? That's the one.
Yeah, it's a flat Earth.
Have you had a debate with a flat Earth or like a an anti-round? Like I don't.
It may have happened at Ask a Scientist.
Oh, really? You did get one?
Yeah,
I was trying to think
so.
back. I don't know if I've ever witnessed that.
That would have been years ago, and I don't remember how I ended up. Yeah, but no. Otherwise, no.
That's the big one. There's no one selling, pyramid schemes based on astrophysics. I mean, astrology is obviously a big.
Actually, there are some scientists who have careers in science who don't believe in dark matter, who don't believe dark matter exists. There are very few of those these days, though. But I did meet them, and it's very fascinating to have a conversation with someone who all right, so dark matter is basically, it's a paradigm that's essentially accepted now. It's essentially accepted. There's just too much evidence in it, and it hasn't been debunked in decades. But when you come across someone who they're a really smart person and they do science for a living, so they're a really critical thinker, and they get stuck on evidence that has at one time it was a big open question, but then some result comes out and says, oh no, that's no longer valid, but they're just stuck on it. And then you have conversations with them on something else, and they're totally rational, but they're just stuck on this one thing. It's fascinating seeing how people do that.
I mean, so the dark matter, is it that they don't think that gravitational mass exists, or they don't like that it's a nebulous unknown, it's a mathematical placeholder? What is their problem with it?
Yeah, so
because the math shows that something is there, right? That's where this came out of.
Yeah, so basically the observations show that. So how do we measure the mass of something? Well, it's by watching something else orbit it. By looking how fast it orbits, you know the strength of gravity. If you know the strength of gravity, you know the mass that's causing the gravity. So the way dark matter is basically discovered anytime is like things are orbiting way too fast for the amount of mass you thought was there, just based upon the lights that there. And so you have to invent more mass, and it doesn't interact with light, so you call it dark matter.
Yeah.
Other than that, we don't know what it is.
I see.
And people were uncomfortable with that, and we still don't know what dark matter is. It's just something that has mass, but it doesn't interact with light. And so people were like, no, something else is wrong. Something else is wrong. It can't be that there's mysterious mass that, like, you walk around on your daily life, there's no dark matter, there's no mysterious particles around. So something else must be wrong. Like maybe our understanding of gravity on those scales is wrong. Like we've really only tested gravity on, locally.
Yeah,
like in our solar
that's
system.
a good point.
We haven't tested gravity. Like we have these inferences, but we haven't really tested it.
So they might be right.
Yeah, but there are tests that have happened in the meantime that yeah. All right, I need to make a move.
Yeah, no, that sounds good.
It is really hard to see. It's fascinating.
Yeah. Matt isn't a robot. I'm still chewing on donut Earth theory. Is that a
What
thing
is
you're aware
donut
of?
Earth?
I'm
Yeah,
assuming
not
that
aware
the
of
Earth
it.
is shaped like a donut.
Oh,
I mean, so the flat earthers have an intrinsic problem because there has to be an edge to a flat Earth. And
Yeah.
supposedly there's an ice wall around the entire perimeter.
okay.
But nobody has flown to this or visited it or...
Actually, students in my class were just asked a question like, "What observation can you make to like disprove like that the Earth is shaped like a disc instead of?" Yeah, maybe we can put it up to people, but yeah, there's an observation you can make. Yeah, maybe I'll just,
you don't want to give away the
Yeah,
answer?
I'll just
Yeah,
give
you
it
might as well.
I'll just give it away. Yeah, so the Earth casts a shadow on the moon quite regularly. And the
Periodically, maybe.
Yeah, exactly.
Predictably.
And if the Earth were a disc, sometimes that shadow would be round, sometimes it would be a line because it's like there's a disc.
The line eclipse.
Yeah, exactly. The line eclipse, exactly. But that never happens.
Yeah.
Like the Earth is at different orientations as the Earth is casting a shadow on the moon.
Yeah.
And it's always round. You only get that with something that's a sphere.
Yeah.
Yeah, so
All right, keep going. People are joining us for the chess. Forget your physics bullshit. Like, let's play some chess.
I'm creating a play. I'm just basically
Yeah, no, you're building tension.
Yeah,
Really.
exactly.
Like, we have
Exactly.
no exchange pieces yet.
yes.
So like, we're building the
Is it?
lore.
It's really thinking.
Yeah. Yeah, if you do it on a higher level, it takes a
Okay,
lot
where's
of
it
time.
going? Is it going to go here? Is it going to check me? I think it's checking me. Yeah.
Oh, wow. You got forked. Well, you're exchanging. It's fine. Your pawn's there.
Oh no, it's going for the pond.
Yep. It's the longest move ever. Speed chess be damned.
Oh, are you kidding me?
Oh, lost,
my
lost
goodness.
his shield, lost his sword, executed. Tis but a flesh wound. Oh, that was it. They didn't. Oh man. So, yeah,
Okay.
you get one of those animations with every
All right,
kill.
so I'm in check. But that's it.
Matt isn't a robot.
Wait. So what is
That's a knight, right?
that? Is
pawn.
is a pawn.
Yep.
So if I take with my queen, I'm not hanging my queen in any way because
Yeah,
there's the
that's a
knight.
Yep.
That's a pawn. That's a pawn.
Yep.
Well, that was just a dumb move. They just hung their knight. Really dumb.
You just waited them out. Waiting for the stupid mistake.
Yeah.
All right. Matt isn't a robot has a question. Sorry, I'll get to this. I document all these for some reason. I don't know what they're useful for.
I think that's going to be my strategy. Yeah, I'm just going to wait them out.
How weird is it that the sun and the moon both take up the same visual space in the sky?
Oh my gosh.
Coincidentally, it's amazing, right?
Yeah. So who asked this question?
Matt isn't a robot. May or may not be one of your students.
May or may not be one of my students. Okay.
It's not one of the follows from your class.
Okay.
But click the follow button if you're not.
Yeah, so... Oh. Looks like they took...
Pawn.
There we go. Yeah, I hung that pawn. I just wanted to see what would happen.
Just got beat to death by a bishop. PJ, thank you for the follow. If you have questions, throw them in chat. We want them. We want to discuss any of your astrophysics or
so
physics
that
questions.
is weird, actually. It's even weirder because the moon used to be closer. So it's only perfectly aligned now.
Yeah.
We wait, millennia, obviously, like hundreds of thousands, millions of years, and it won't be perfectly aligned. And so anyway, for those of you who are unaware, the moon is much smaller than the sun, but the moon is closer. So the apparent angular size of the moon on the sky turns out to be almost the same as the sun. The moon's orbit is elliptical, so it's sometimes a little bit closer, so it's a little bit bigger, sometimes it's a little bit farther away, and it's a little bit smaller. And that's why we get these nice, beautiful, like perfect solar eclipses, or sometimes it's a little farther away, and so we get this annulus in the solar eclipse. But that is only the case now. The Earth and the moon are 5 billion years old, 4.5 billion years old. And so just a billion years ago, that wasn't the case. The moon was much closer. And soon, within a billion years, the moon will be farther away. And what's causing that are the tides. So here's the Earth, here's the moon. The moon's orbiting about the Earth. The moon is causing a tide on the Earth. And as the moon goes around, so the Earth is spinning around much faster than the moon is going around. And the rock is spinning, every 24 hours. And the ocean tides are pointing towards the moon always. So the rock is spinning underneath the oceans as they have these tides. And that's causing a friction. And it's slowing the Earth down. But, you have conservation of energy. So where's that energy going? It's actually going in making moon's orbit bigger. So it's giving energy to it. And it's pushing the moon out. And so, that's what's happening to the moon. So it is weird, actually. Not only is it weird that it's just coincidental, it's weird it's coincidental right now.
So, it's an elliptical orbit, so the size does change. Can we resolve that visually? You can see the difference?
Oh, yeah. With,
it's obvious enough.
Yeah.
I mean, human eye resolution is 1 arc second. How is the...
So I don't know if the human brain can tell that difference.
I see.
But when you take pictures,
you can actually quantify it.
Yeah.
Okay.
When you take pictures, and then you have a scale, and you're like, oh, I can measure that with a ruler. Obviously, the moon is a little bit closer now. Yeah.
All right. ANS75903. Thank you for joining us. It's a student from class. Thank you for the follow. We appreciate it. It helps with the visibility of the channel. Thank you for joining us. The question is, in class, you said you can tell a planet is made of a certain chemical by looking at the same chemical on Earth. But how do you know the planet isn't made of a new chemical that we don't know exists yet and looks like the one you tested? Oof. The answer is you can't.
Yeah.
But the likelihood.
Yeah. So if it looks like a duck's, quacks like a duck, all that, it's a duck kind of thing. So what this student is referring to is I introduced an important concept called the cosmological principle, which basically says that the physics is the same everywhere across space and time.
Because we have to assume that.
We have to assume that because if that were not true, then science wouldn't work.
That's
period.
Like Descartes. I think, therefore I am kind of thing. Yeah.
So, and so I was introducing the fact that, how do we know that, stars are made of hydrogen? Well, we look at hydrogen in the lab here, and it has a certain signature when we look at the light. Then we look at a star, and it has the same signature. Oh, it's made of hydrogen. And then, the student is asking, well, how do you know it's just not some other element that happens to look like? So
The answer is it could be.
It could be. At this point, the probability of that happening is minuscule.
Yeah.
Super minuscule. Because we have explored many of the elements and we know what they look like very well now. There are very few new elements that we've discovered. So if you find something that looks exactly like something you've already discovered, it's most likely, this is where Occam's razor comes in doing science, is the simplest answer is usually the truth. Usually.
I mean,
Not always.
It also points to the beauty of science, right? Every single one of those claims is falsifiable, right? If somebody finds an additional piece that says it's not that element or molecule or whatever, you have debunked decades, centuries of human knowledge, and that's awesome.
Yeah.
But that doesn't happen, right? Hydrogen line spectra always looks like the hydrogen line spectra. The red shifts and blue shifts are always the same. Like no, it's really elegant, actually.
Yeah, it's a profoundly deep aspect of science. It's fascinating.
It's underappreciated because people like just want to defer to authority and say just scientist, here's the answer, but at our foundation we want to be wrong. Right? Like we want to be disproven or want to show theories are wrong, and it's really underappreciated. It's part of the elegance. All right, sorry, you got to do a move.
No, that's all right. Let's see. So
Matt isn't a robot. He's gotten epistemological here. I imagine that the moon sun size coincidence instilling a feeling of mystery, curiosity, and purpose as humanity came to be. Man, that's one of the things I love about humanity is that since the beginning of human perception, all we have done is knock ourselves off of our pedestal of superiority, right? Like we're the only living thing that exists and can think, and then animals can think, and octopus can think. We're the only one that can make molecules, or we're the center of the universe. All that shit has always been wrong.
Actually, in in like an astronomy 101 course that I'm teaching now, kind of one of the main themes of it is humility. Because that's like fairly soon I'll be introducing that, and the kind of the history of how we see the universe, and it's always like, oh, we're at the center, and then we just keep going away from being at the center to being very insignificant in the end.
Pale blue dot. Carl Sagan, the quote.
Okay. All right, so we got this. This is a bishop.
All right.
So the bishop is.
Are you good on drink, or do you want another one?
Yeah, I can take another.
10 o'clock.
Yeah. The bishop is attacking that knight, and nothing else. So there's nothing protecting this knight.
Are we done with the bourbon? This class is out.
I don't know.
All right, I'll leave it here. All right.
Oh, you know what? I can just advance my knight. I'm pretty sure this is a knight.
I mean, that's a really good point. Looking into just the sky and saying those are the similar size. What hypothesis can I derive from that when it was just a coincidence?
Yeah.
That makes sciences hard, right? Across the board, just hard.
Yeah. Yeah, that is a good point. Yeah. That is just a coincidence, and humans love clarity.
Yeah.
We love clarity, and we love we will adopt models even when they're wrong, but as long as they provide clarity.
As long as they feel good.
Yeah.
Right. Yeah. I mean, that was one of the arguments for flat earthers, why it's not because they necessarily believe it, but the sense of like superiority and understanding that no one else has is like a rush, right? Like it's an intellectual drug that they like to have.
Yeah.
And it's the same thing with conspiracy theorists, right? In terms of politics or whatever it might be.
Okay, I just hung a piece, and I didn't even realize it because I couldn't tell what the piece was.
Murdered.
I'm not sure what happened. Actually,
that
was a knight. So where was it?
That's right there, but you're protecting it with the bishop.
No. But I had a knight here.
Yeah, but it's not hung. You have a pawn.
There's a bishop here.
Yeah, and then
there's a pawn there.
Yeah, you can take him.
I'll just
You're
take
trading.
him with the pawn. Yeah.
Yeah, it's not a complete loss.
It's not. Yeah, it's not a hang. It's a
and
it's a trade. But I didn't see the knight.
Yeah. Whereas anyone joining us from the chess Twitch subcategory, feel free to add your comments accordingly. We don't take them personally.
Yeah.
All right. What do you want to add? Let's do another prediction.
All right. I'm curious to know. Let's see how people will do with. Can we say all this stuff without?
Yeah. You can say that before.
Let's do it.
So yeah, give context, and I'll start uploading this.
Okay. All right. So, the four fundamental forces of the universe, in order of strength, from strongest to weakest, are the strong nuclear force, electromagnetism, weak nuclear force, and gravity. All right. So I'll say that again. Order from strong to weak. Strong, electromagnetism, weak, and gravity. In other words, strong is the strongest and gravity is the weakest. Nuclear bombs rely on the strengths of the strong and weak nuclear forces. That's basically what they're using when they blow up. All right. So the largest explosions in the universe, therefore, must rely on the strong and the weak nuclear forces. True or false?
I like it. The strongest explosions in the universe, which you're not going to give away. Celestica, what about the force of love? Well, they just negated your question.
You're right.
Maya, quit your career. Celestica, I hope you made that discussion earlier when we were talking about Interstellar.
Oh, yeah, that's got to be. Yeah, that's got to be.
Like we're praising like how good Interstellar was until that line, like one sentence, just God. Anyway, that question is an entire essay. At the very least, it is. But yeah,
this.
Go
What
ahead.
is that? Is that a knight or a bishop? Is that a knight?
That you're highlighting?
Yeah.
That's your queen.
Oh, yeah. There you go.
Not sure if fan of Interstellar or Back to the Future. The power of love transcending time. We're not going to dive into that one. but thank you, Celestica117. Thank you for joining us. Click the follow button. Follow us. It helps with our visibility, but also thank you for the comment. If you have any astrophysics questions, also we have a pending prediction right now. Click that predict button. The question is, there are four forces in the universe. There's strong, there's electrostatic, there's weak nuclear forces, and then there's gravity. And so the question is, the largest explosions, what's dictating it? Does it rely on strong and weak nuclear forces? True or false? Or is it just one of them? Or is it neither of them? Answer the question accordingly.
Oh, here we go.
Oh, somebody went the dark horse vet.
Yeah.
So, largest explosions rely on strong and weak nuclear forces. True or false? Maya, what is the correct answer?
False.
False. 98%. They were very confident in their answer.
Yeah.
So I think Cuddle Puppy went the dark horse bet on this one. Because it would have been a 41-1 payout. All right. So what did the I'm going to move some cans while you explain this answer.
I'm wondering if is it worthwhile to have feedback on here? Like, can someone tell me, what do you think the answer is? What force dictates the strongest explosions in the universe?
Oh yeah, just give them some time to answer.
And I will play some chess. The force from Star Wars. Clearly, that's the answer. Matt isn't a robot, says gravity. Anyone else?
All right. Did you get an answer from chat? Gravity. Gravity is not right, is it?
It is gravity, actually.
Holy cow. I would not have guessed that.
Yeah, gravity is the answer. So the largest explosions are the explosions of stars, basically. And what initiates them is actually collapse, like gravity collapsing things. And so when, like, we've got this. There we go.
There you go.
We've got this. And if I were to drop this, gravity, through the act of gravity, when it hits, all that kinetic energy would turn into, like energy of breaking it apart. And that's essentially what happens in the cores of these stars when they collapse. Like they're collapsing, they collapse near the speed of light. And then when they get to really high densities, they stop the collapse. And just like when my hands come together, it makes a sound wave. When it stops the collapse, it makes a very strong sound wave that actually is a blast wave. That's what a shock is a strong sound wave. And that blast wave goes on to explode the star. So the strongest explosions are almost always initiated by gravity, actually. And so even though gravity is the weakest force, all the other ones are either like short range or they get canceled, like the electromagnetic. Like the universe is neutral. Mm-hmm. So, even though like the electric force can be long range, there's always something to cancel the positive or negative charge nearby. And so it ends up not being long range. The strong force is short range by nature, and so is the weak force that's also short range. So the only force that's left over that can be long range is gravity in many cases.
Yeah.
And so even though it's super weak, you can just accumulate a lot of mass, and then it ends up dominating in situations like this. And in fact, it's so powerful that like in these supermassive black holes, when stuff falls into them, they can convert like a fraction of the rest mass energy. So, you take mass, multiply it by c squared, and if you annihilate all that mass and turn it into energy,
that's a shitload of energy.
Yeah. So it turns out like just falling into a black hole, you can extract like a large fraction of the rest mass energy of objects just by falling into a black hole, just through gravity.
Yeah. All right, Maya, you got 14 minutes to beat this chess game.
Oh my gosh.
No pressure. You're on speed chess mode now.
Really?
Should I force you?
That's impossible.
14 minutes? Fine. We got to play NARC. We got shit to do tonight. I think it's developed enough. It'll unfold quickly. All right. J Bisler 5. Maybe this is similar to a question from before, but what is the unusual state of chemicals found in stars being born or dying?
Wait, what? What's the...
So, what is the unusual state of chemicals found in stars being born or dying? Like, are there, I guess the way I interpret this is, are there chemical, molecular, atomic signatures of a star birth, star death?
Oh, yes, there
star
are.
death, like heavy elements.
Yeah, there are. So, basically, I think it's time to transition to NARC. I'm concentrating on this chess game.
Unless it's going to take you 43 minutes to beat NARC. Keep playing chess.
Oh, okay.
Yep.
I thought we had 14 minutes.
Yeah, we have 14. Well, I'll give you a half hour to beat NARC.
Oh, I see.
So yeah,
okay,
it's only
got
10:18. So
thanks. Okay.
Yeah.
All right. So yeah, yes, there are. So like iron is produced in these stellar explosions. Silicon is produced in stellar explosions. Things like that. So when we carbon and oxygen is produced. So we see a lot of those elements. We call them iron peak elements and then alpha elements. So basically, we're talking about like there's a peak around the iron. So there are other elements besides iron that are made similarly. And then things like oxygen, carbon, silicon, magnesium, those are all built up by basically, throwing helium nuclei at smaller things. All of those things are made in explosions. Now, there's another type of explosion, which is the merger of two neutron stars, and it's thought that that makes stuff like gold and silver and things like that. They're really heavy stuff. is made in the merger of neutron stars.
So fusion reactions, I don't know the nuclear chain as much as I should, but like iron is the biggest thing you make in fusion in the core. Is that right?
Well, it's you can make heavier things. It's just you don't get energy out of it.
I see. It's a diminishing returns.
Yeah, exactly. Iron
Yeah.
is the biggest thing that you. So if you fuse hydrogen, and you make helium, then you get energy out of that fusion. And if you take helium and then you take several helium, you make oxygen, carbon, you get energy out of that. And you go all the way up until you get to iron. Now, if you start adding things to iron, you actually lose energy when you make heavier things. And so in certain explosions, like the ones that I study, you mostly make like carbon, oxygen, and iron. The neutron star merger is a special case where there's a lot of opportunity to throw extra neutrons at the things. What you basically do is you take a seed nucleus and you just keep bombarding it with neutrons to build up the heavier things like lead or gold or things like that.
All right, Celestica, thank you for the follow. Thank you for joining us. Thank you for the questions, discussions, any comments you have. Just do it, Maya, commit. Just do like 30 moves in a row. Let's see how this unfolds.
Okay.
Have you ever played like timed speed chess, like the 2-minute punch clock?
I haven't. Oh, and I just hung a bishop. Look at that. Good job, Jeremiah.
No worries. But the pawn got the satisfaction of putting a bishop through the floor.
What? That's weird. That's very weird. All right,
pawn.
let's get rid of this pawn.
Oh God, it's gonna check you with a bishop too.
Yeah.
That's we'll see how this unfolds.
Yeah. Yeah, I remember I saw a queen up there that's also staring at that same one. Huh.
I mean, the scale of forces is very counterintuitive to human existence,
Is
right?
it going to do it? Yeah, it's going to do it.
Because, like, and this is something, like, people don't appreciate, is, like, gravity doesn't kill you on a fall. It's electrostatics when you land, right? Like, because electrostatics is so much stronger. And it's, gravity is something, like, anyone that's skateboarded or skied or anything like that, gravity is the biggest thing you care about, or skydiving. But it's electrostatics is so much stronger. I heard a calculation once that basically if you could isolate the charge of the Earth and put like 5 electrons on Earth and then 5 positive charges on the moon, you could drag against gravity. Like that electrostatics is so much stronger than gravity itself.
Wow.
Like, and I mean, you know these scales more than I do, right? It's a lot stronger.
All right, I'm gonna have to really pull together a.
Skydiving would be pretty boring without gravity. I don't know. The free floating in space, they seem to have fun. The vomit comet, just hanging out, and I guess it is falling technically.
All right, I need to do something about this bishop. All right, so
Yeah, I don't think you have a choice.
if king moves over, is that a trap?
I don't think you have a
I don't
choice.
think so.
Or I guess you could
I do. I could
sacrifice
the queen or the rook.
I'm like 3 drinks in. None of my opinions are worth
Wait,
out.
what? Oh, something. Okay, there we go.
Oh,
I
you
got it. I
selected
had to
something else.
unselect that one.
All right. Those of you planning on playing BattleChess, new insights gained. All right, let's do a fun question, but you have to keep playing while I ask.
Okay, all right.
Unlimited budget, no moral qualms. What experiment would you do?
Unlimited budget, no moral qualms.
Like you could build the biggest satellite in human history. You could shoot people at the moon. Like what do you want to do?
I know what I want to do. I know what I want to do.
All right.
Actually, yeah.
Turn the moon into a...
No, I want to build a large telescope that allows us to look at the atmospheres of nearby planets like the Earth. And I want to look for biosignatures. I want to see if there's oxygen in other planets, like just nearby. That's what I would do. Can I play chess with you? Yeah, sure. Let's do it. Are you? I promise I play chess better than this. Not much better though.
So, anyone just joining us, a key part of Ask a Scientist Gaming is not just the talking science and gaming, but also the drinking alcohol while doing it. And so we get progressively worse at this through the night.
That's actually not my problem. My problem is I can't see the pieces.
So
I've hung like 2 pieces.
It will only take 6 hours. Talking shit.
Only, yeah. All right,
You came here to be humbled, and they have achieved that goal.
I think I like this tension here. I like this tension.
Oof. Because you're at even pieces, they're one up on you.
Oh, what's she doing?
Going for a pawn.
She's going right behind the bishop.
All right.
So does she want to do a queen trade?
Or take your bishop uncontested.
Oh, yeah, I see.
Oh, it's a sacrificed fork. I like it.
Yeah.
If anyone has suggestions, Maya's happy to hear them. He's got 5 minutes till NARC. Lol. That queen strut, she's on a mission.
Maybe the only thing that I can do...
I demand that everyone in the stream right now downloads or goes to a website and plays the emulator of BattleChess. Totally worth it. By the time you finish this chess game, you'll be sober.
All right, so take.
So in Maya's defense, I hope you guys appreciate this. The trying to converse, talk science, answer questions, and enjoy your time while playing video games is an unpracticed skill not a lot of us have. So I encourage many of you to sit down and play video games, but start casually chatting about astrophysics.
I definitely have an appreciation for all of these Twitch streamers and YouTubers who play games and chat. Yeah. Holy cow.
And even if you're a gamer, if you're not used to talking while doing it, it's definitely a challenge. That's for sure.
All right. So yeah, I'm in trouble. There's a fork here. Mm-hmm. But I'm just wondering if I can take.
I think you have to trade.
Do I have to trade my queen?
Yep.
What if I take here?
It's trading rooks. I guess that's 2-1. You give up the pawn? Yeah. All right. Joseph wants to know, today you mentioned that protons and such are made up of particles, and I know they're called quarks, but what are quarks made of? Oh, man, we're going to go the Atomos argument, right? Keep cutting it in half. At some point... That's what I love. Greek philosophers back in the day, they were just sitting around getting drunk, talking just whatever, and they said, okay, you break up a particle and it goes in half, you break it up again, goes in half. You can't do that indefinitely. At some point there's fundamental building units, and for a long time we thought those were atoms, and now there are things like quarks. And are quarks made of something? Vaporized, as the queen does.
All right, there's no surprise what's going to happen.
What is your thought? Are quarks made of something?
Let me think about that. So
asymptotes, exactly. This is why calculus was invented, because none of this shit makes sense.
Asymptotes. Oh my gosh. Did you see what just happened?
No.
How the rook ate the queen?
I love this game. Totally worth it.
All right. I'm just throwing away pieces here.
What do you think? Are there something smaller than quarks? Quarks are a relatively recent thing, right? That's the last 50 years or so. That's been experimentally.
Yeah, quarks are relatively recently. Where are you going? Are you going to take my...
They got a bishop protecting.
Yeah,
I didn't see that.
I didn't see that either. Ah, it's so frustrating. It's so hard to see the pieces.
Don't worry, this will be on YouTube forever. Oh man.
Oh, I have. Yeah, I'm all good. I have zero attachment to this game. I'm mostly intrigued by it.
Yeah.
That this was even a thing.
I mean,
Well,
one of the early Alex, thank you for the follow. Thank you for joining us on Ask a Scientist Gaming. It's 10:30. We should probably do a prediction, but we should also probably transition to NARC.
all right, sounds good.
Joseph, thank you for the follow as well. Thank you for joining us. Again, astrophysics question, ask them. Let's finish the quarks question. Do you think there's a something smaller than quarks?
Yeah. Yeah, I do, actually.
And that's because intuition, or because of there are hints that there are smaller things?
We know the standard model is incomplete.
Mm-hmm.
So we know it's not right. It's the best that there is.
Yep.
And just the history of way things have been going. And there are theories to explain these things, like strings, and for example, like there are more fundamental things than the particles that we have. So yeah, I suspect that there's something more fundamental than quarks.
You know what's more fundamental than quarks? NARC. Are you ready for this? Right. So, ladies and gentlemen, anyone that's not familiar with the stream, Ask a Scientist Gaming, we close every single stream where I force my guests to play NARC, which is a bargain bin game for the Nintendo Entertainment System, written, directed, and programmed by Nancy Reagan. You're going to win the war on drugs.
Are you serious?
No, I'm not.
I really hope that's true.
Just say no. This is a bargain bin game, ladies and gentlemen. So we make every guest play this. Not only do that, but we time them as they play it. So Maya's goal
Wait. What's the goal here?
And time-wise,
Yeah.
the fastest time of any of my guests is about 17 minutes. The slowest is probably about 40 minutes.
Wait. I'm doing what though?
Beating it.
Beating the
You
whole
will
thing.
beat the game. Yeah, you have Game Genie. You have infinite lives, infinite bullets, infinite rockets. You will beat this game tonight.
Okay.
You actually can't leave until you beat it. So press start. Let's go, ladies and gentlemen.
All right, here we go.
Was that a threat? I don't know. But we are playing NARC. We better get
Pipeline
out of
had it. All right, here we go.
chess. All right, there's your clock. If you want additional pressure late at night, walk right. You don't have to kill anyone. There's
I just
no
wanted
value
to
in
kill
killing
him.
anyone. All right, so we do think there might be things smaller than quarks. We just don't know because our models are incomplete, obviously. So
Yeah.
that's kind of fun. All right, George Jettison wants to know, past or present, who is your favorite scientist?
Oh, I gotta go through this door. Einstein was a good guy. Galileo.
Pretty good.
Yeah. Yeah, there's a lot of favorites. You know, Carl Sagan. Very fun in terms of the way he thought deeply about things. Oh, hey, get up.
I mean, not just deep, but like broadly too.
Yeah.
Like he understood context of these thoughts.
Yeah.
Oh, but Einstein did the same thing when he was like writing
Yeah.
letters about nuclear bombs,
Yeah.
right?
Yes, that's certainly true.
Like it takes a step outside of the lab to
Yeah.
contextualize the implications of what we do. So if you had to pick one, Sophie's choice.
I think Einstein. I know that's a bit cliche, but yeah, there's a reason.
I mean, you got relativity, right?
Yeah.
You got general relativity.
Also,
You've got-
the way the guy carried himself through life with confidence and humility at the same time.
Mm-hmm.
Yeah, there's something special there. Oh,
was offered the presidency of Jerusalem.
what? Seriously?
Yeah, of Israel. Sorry. Yeah, and he said no.
Oh my goodness.
Yeah.
Yeah.
Or was offered to run, I guess. But I mean, what's incredible about him is his Nobel Prize was for photoelectric effect, right?
Yeah.
But he also, I mean, relativity, obviously
Yeah.
a very big one. Photoelectric was huge. He proposed lasers 60 years before they even existed. Like, one of the most gangster, like, scientists of all time. Like, GPS matters because of what Einstein said.
Yeah.
And that's absolutely profound to me. So, All right, I better get us out of the chess. Let's go to science and technology. All right, so we're going to catch up on a few questions.
All right, this one, I've been doing horrible at games, and I'm determined to...
Yeah, just walk right and find doors. That is your only goal. If you press both buttons, you can shoot the dogs. So that door right there, you need to find a blue key by shooting one of these guys at close range with bullets instead of rockets. Excuse me, sir. Laser is a registered copyright. Our lawyers will serve. Yeah, write an angry letter.
A blue key.
Oh, Huggy Beer. Evening, folks. Huggy Beer redeemed to request a factoid. Do you have a factoid you want to drop on the audience? Just a scientific tidbit. So hold. You're going to shoot bullets. Maybe you have a blue key. Check. Go to the door. I haven't been watching. Maybe you grabbed it already.
All right, come on. Get up.
Light amplification by stimulated emissions or radiation. It didn't open? Okay.
Yeah,
So now
alright,
bullets. Those guys close range.
I am shooting bullets, right?
Yep. Yeah, if you shoot they do that if you shoot a rocket. So this is...
Oh, so it's double?
It's a tap, it's a rocket. If you hold the button, it's bullets.
Okay.
So you can't shoot them at the edge for some reason, and you can't shoot them long range. You have to walk up to them and shoot them close. But not too close because you arrest them. So he dropped something, but that's not the card. So that's your goal, is shoot. So this is something in the speedrunning community they call RNG, or random number generator.
Yeah.
Because the card drop is random.
Yeah.
You might have gotten it. Try the door again. Like, go up to the side. Go touch that thing. Further right. No, you don't have it yet.
Oh, Lord.
Yep. This is part of the thing that kills the speedrun. I speedrun this game, actually. And so this is one of the things you just like, there it is.
There it is.
So
Yay!
you just play this and you hope it drops in the first half second of doing that.
And then you
if
got
not, you hit reset and you try again.
Okay,
All right.
let's go. You're going to have to remind me of the question.
Osifum0731. Okay, I have another question. Is it theoretically possible to fold space-time to travel faster? Like wormholes. Is that
Yes.
what we're talking about?
Yep, exactly. Yep, wormholes. Also...
Walk right.
You're right. Stop doing what you're doing, Jeremiah.
Killing people feels good.
Just walk right.
Just walk right. All right.
Yes, so wormholes is one aspect of it, but warp drives. Remember I said we're going to come back to that? Mm-hmm. And I said, so how is it possible that Star Trek can go faster than the speed of light? Because they're doing that. They're going faster than the speed of light in their... It's because when you warp space-time, you can actually make space-time go faster than the speed of light. The things in space-time are going faster than the speed of light, but you can warp space-time to go faster than the speed of light.
So you can jump in the car.
Jump.
So tap B.
Tap B, tap B, tap B, tap B.
A little faster.
I gotta beat. Haha!
All right. Now you're going to run into a wall. Who could have ever predicted that? This happens to everyone. At some point, I'm going to make a compilation of every guest running into that wall. It's just going to be that
Because we went to the middle, not below.
You have to memorize a pattern that obviously you don't know.
Yeah, exactly.
But next time you're on stream,
yeah,
you
that's
will
what's going to
practice
happen.
this.
I'm going to go down low.
Don't worry, I made a speedrun tutorial, and it's on our webpage.
This guy.
Man.
Oh,
All right.
so this wall
Start
is...
You can jump over it. Tap B. You can jump over. Yep. There you go. And saunter your
jump.
way. It's not a walk. It's a saunter, ladies and gentlemen. All right. Folding space-time. That's what warp drives do in Star Trek,
Yep,
right? But
exactly.
in physical reality, is that something discussed?
Oh, okay. So to develop... All right. So to be able to actually make your little bubble of space-time go faster than the speed of light, what you have to do is you have to make the curvature in front of you that's like a black hole, so like fall into something. But behind you, you have to do the opposite of what normal gravity does. So like normal gravity is like it makes wells, you fall into them. But you have to make something that makes hills. And theoretically... dark energy, that's what dark energy does, is it makes hills. All right, you need to go away. Dog.
So-
You just need to go away. There we go. So that's what dark energy does, is it makes hills in gravity. And so if you put dark energy behind you and like something in front of you that's like normal matter or dark matter in front of you, then it makes this thing that basically pushes you along.
So stay on the bottom.
Oh!
I tried. I tried. Oh man.
Oh my gosh.
Sorry, dark matter hills.
Yeah. So basically, you need to create a something like a black hole in front of you and a white hole behind you, and it will push you along, and you'll be like a surfboard riding a wave, and you can go faster than the speed of light. Basically, what you're doing is you're taking your little bubble of space and going faster than the speed of light. But we don't know how to make that matter. Like whatever dark energy is, we just don't know how to do it. We don't know how to do it. We don't know what it is. We don't know how to make it. We don't know how to harness it. So
Huggy Beer premonition. Do we have a theory on how to make dark energy?
No.
The answer is no. We don't even know what it is.
Yeah.
Right? Like it's a thing that's there. That's really intense. I mean, I heard one of my chemistry colleagues complaining about this at one point, like how hard it is to be in astrophysics, because like mass balance is a thing in chemistry. Like if it turns into something else, you can still quantify it had to be this and this. And you guys just have dark matter hanging out there, right? Like it's just like our mass balance is a fudge.
all right,
Stay on the bottom.
I'm gonna say staying on the bottom is what you do here.
It'll give you more time in the car.
Just lock in the bottom.
It's perfect. Totally worth it. No.
Oh, there we go. Okay.
Yep. Now you're at the end of the level. Oh. Sorry. Did we address Huggy Beer's request a factoid? Did you drop a factoid?
I did not.
All right. Let's do a
drop a
factoid. Tap B. 7
there we
frames. There you go.
Oh, good grief.
Aren't you glad we closed with this?
All right. Here's a factoid.
All right.
The recent fusion result, right? Because everyone heard the result. The result was they fired a bunch of lasers at a tritium pellet, and they got more energy out than they put in the laser. The problem is, all right, that's
a clown with a knife.
Yeah, this person needs to die.
Just walk away. You have nothing to prove here. they keep coming
Just walk
back.
away. That's good. That's good life advice.
It really is. Oh man, but actually, it is good life advice.
It's excellent.
Like
so, there's multiple exits.
You go to the far right one. Nope.
Oh crap!
No, just go right. You'll find a door. When you go through it, press. But that's actually true though. Like thinking about it when I was younger, like I have a black belt in karate. I won a national fighting championship. And I'm like, there's so much pride behind that ability, right? But then when you think about it, like one wrong hit could change your life, right? Like in terms of being debilitating, in terms of damaging you, brain, physical ability, and it's just not worth it.
No,
like,
it's not.
never worth it, right? And so like walk away.
Yeah.
You have nothing to prove. You have nothing to gain. Eat your pride and don't end up in jail. Don't end up damaged. And press left up.
Oh crap!
No worries. It happens to everyone. But yeah, anyway, don't damage your pride. All right, did we close out that factoid?
No.
All right, sorry.
Darn it!
Don't after you go through the door.
Don't push up.
Yep.
Yeah.
Anyway, the fusion reaction, the energy out was like 50% greater than the energy in.
Well, kind of.
Yeah. All right, so now you're going to that key card. And then go through the door.
Yeah. Go. Okay. It was all right. So the way they do this is they fired a bunch of lasers to compress something so that they could have nuclear fusion. The energy that came out of the nuclear fusion was more than they put in the lasers, but they had to build up energy for a while ahead of time to store, basically to fire the lasers, right? It turns out they had to build up 300 times the amount of energy that they fired in the laser.
This is the only one you'll walk left. Watch out for the weed plants.
Yeah, apparently they're very poisonous.
Yeah, this is Florida weed.
So anyway, this result, while it's exciting in some ways, there's still like giant, like a factor of 300. That's a problem. Oh, so I need to kill someone to get a card.
So you need to kill the Rambo-looking guy with bullets at close range. So kill that guy, and then Rambo will come on screen. Huggy Beer, yeah, I saw the 60 minutes on the fusion reaction. The laser took 100 times the energy put into the reaction or something, right?
Yeah. It's so basically, you know, the amount of energy you put in the laser, if you got that amount of energy out, then it would have been fine. Then it would have been 50%. But yeah, it was like 100 times the energy.
Oh, there it is.
There it is.
Green card. Nice. All right, door.
The 100 times the energy it takes to to fire the laser, they just had to build that up. Oh, I got to go over there. Now I got to do that. Okay, I got it now. And so, yeah, that's an efficiency of 1% when it boils down to it. So, and those are major engineering challenges.
Yeah.
That I don't know if those are going to get solved anytime soon.
I mean, my understanding is the optimism is if you can sustain it, that initial buildup doesn't matter, right? If you could continuously run this and get a 2-to-1 return, then you would eventually get your return on investment.
No.
That's not.
Well, if you could, no. That's not the way this one works.
I see.
Because the way it works is you need to have energy in the laser, because it's the lasers that they're basically what the point of the lasers is to compress the tritium pellet to the densities and temperatures so that you can get nuclear fusion. So you always need the energy in the lasers.
Yeah.
So if you're constantly having to build up energy in the lasers, and it takes you 100 times the energy that you actually fire in the lasers, then you always lose.
So is it literally just physical force exerted by the lasers? Like
it's pretty much that. Yeah.
It's photon force?
No,
how does that work?
No, what's happening is the lasers are basically ablating the surface of the pellet. The surface of the pellet is not tritium, but the surface pellet is something else. I don't remember what it is off the top of my head. But it's ablating away that stuff, and that stuff is coming off with such high velocity that it's causing, for every action there's an opposite and equal reaction.
Yeah.
It's basically like it's causing little rockets on the surface of the pellet.
Matt isn't a robot says it's diamond.
Oh, it's diamond.
That's intense if it's diamond.
Oh yeah.
That's all right. Goose has redeemed take a drink. So Maya, cheers. It's getting late. We're playing NARC. Ladies and gentlemen, thank you for joining us. Anyone just joining us, Ask a Scientist Gaming, mediocre gameplay, expert science. Click the follow button. Follow us. It helps with our visibility and getting attention out there. Honestly, we're just doing science outreach for fun. Thank you for joining us. We get to play some video games and talk science. Our guest today is Dr. Maya Murphy, who's an astrophysicist in the physics department at Florida State University. He talks about things like supernovas and models of that behavior and black hole formation. Is happy to answer any physics questions you have in the next 13 minutes as he beats NARC and wins the war on drugs.
Oh my gosh.
Did you expect it to be like this? So I send a random email to people saying, hey, do you want to play video game and drink and talk
and
science?
then you're like, sure.
And I promise it's a lot of fun, but that's a weird ass question to ask my colleagues.
So I've taken 16 minutes so far?
That's your clock. Yep.
Okay. All right, go.
So Huggy Beer, right at the surface had to be super smooth, so they make a bunch and they can only use a small percentage of those.
Yeah, exactly. Yeah, it has to be super smooth. Yeah, it's basically like, imagine trying to take putty and squeeze it with your hand, and the putty will squeeze out your hand. So you have to do all of this very carefully. That's actually one of the reasons why it took them so long for this particular one. Oh, I thought the door opened. Nope.
All right. I got another question. I haven't added this yet to my standard list, but I want to. The president gives you a phone call because some emergency happened and your expertise is necessary. What is that emergency? When are you the go-to expert on the planet that the United Nations or President of the United States needs you to solve that problem?
All right, how about an asteroid coming to Earth?
Is that
asteroid coming to hit the Earth?
What makes you uniquely qualified?
I don't know.
Well, I like this question because it's a very humbling experience for us
Yeah.
as scientists, right? Because
Yeah.
we have such a niche expertise that there are a dozen of me anywhere on Earth,
Yeah.
right? Like, I have a very specific. It would have to be like metal ion linked multilayers are trying to invade, and you need to know the orientation of those. I would solve that problem. So for yours, I guess it's the recent problem you think you guys have solved. Like, how do we manufacture that into a sci-fi enemy? Right? That's what it would take.
Yeah. I don't think that's gonna happen. Oh, is that? Nope. That's just.
Yeah, you got to shoot the guy. I'm glad you got the guy with rockets. I haven't even coached you through this. The wheelchair guy, you have to hit him with rockets 3 times.
Rocket with 3 times.
Yep. So you got him once. So shoot all these guys. This is one of the few places. There you go. Number 2. All right. Inchworm, and then you got to get him once more. If an asteroid's coming to Earth, should we teach miners to become astronauts and drill a hole and detonate it?
No.
Like a nuke?
No.
This is a reference to Armageddon, which was a documentary filmed in real time in the 1990s, as narrated by Aerosmith via song. Thank you, Cuddle Puppy. I don't know. There's got to be a certain amount of... So tapping gives you the rocket.
There
Nice,
we go.
nice. That's 3. All right, gold card. Perfect.
Leave me alone, dog.
How accurate is the movie Don't Look Up, if you saw it, to real life in terms of how asteroids are detected?
Oh, isn't that the one with
I know.
yes, I think I saw Don't Look Up. It was recent.
It's Julianne Moore and Leonardo DiCaprio, Jennifer
Yeah.
Lawrence.
Yeah,
It's the
yeah,
Netflix
exactly,
one.
exactly. How did
is-
they detect it? I don't remember how they detected it. Actually, I remember being really frustrated with that movie in the first 5 minutes. I was
You know,
I'm talking about finding calmness in my life, and I get frustrated with this
yeah,
stupid movie.
yeah. Where's your emotional intelligence now, Maya? I'm sure you would have made it in that career. Oh,
All right,
man.
so am I supposed to kill this guy?
Yes. Okay. So I'm going to coach you through this first before we get back to Don't Look Up. So you're going to walk away from him. I would stay at the top of the screen because his tongues can't hit you. Those are his tongues. So you're going to walk away from him.
I'm trying.
Yeah.
I'm trying. He's
No,
just like on me.
just hold one direction. And you'll get away. Yep. Go right. Yep. Maybe jump. Tapping B will get you away from. Yeah, there you go.
There we go.
Okay,
yeah.
so walk away from him a little bit. You're gonna have to turn around and jump and shoot him in the hat with a rocket. So it's gonna be a
okay,
tap
jump.
B and then
Yeah.
tap A. So
Okay.
get some distance, turn around, tap B and then A.
Oh.
Yeah, you don't want to walk towards him. Just keep your distance.
Okay, got it.
Pause, tap B, and then when you're in the air, you have to tap A. Yeah, just like that. A little faster tap, and you would have had it.
Okay.
All right.
Oh, this is gonna kill me.
Yeah, no, this will take some time. So
Oh.
go the other way, and you'll do it again. Sorry, this is terrible, by the way. I apologize to every guest for making them play this. All right, so turn back now and just stand still. Tap B, and then in the air, tap A on the way down. There it is. Okay, rockets in the face. So walk away, and you don't have to jump anymore. Just shoot him right in the face. What happens if you run out of rockets here? Cuddle Puppy, if we don't have Game Genie, you just die. And so when you die, you get 5 additional rockets. So tap rockets. Tap A to rocket him in the face.
Oh, tap A. All right, hold on.
But yeah, Cuddle Puppy, it's very frustrating because you can run out of rockets and bullets. There you go. Okay, so now you're going to walk away and you're going to bullet him in the spine, but you can't do it at the top of the screen. I'd move down, turn around, and shoot him. So hold A.
Bullet him.
Yep.
Got it.
So walk away, turn around, hold A. So yeah, you can run out of rockets and it's impossible to beat them if you have no lives left. So yeah, very frustrating. Very soft locky. All right. Man, do I have any final questions I want to pose here? Or anyone else, if you guys have questions, Maya's happy to answer those
what
next
was it
7
we were
minutes.
just talking about?
Don't look up. Sorry, we didn't
Oh,
close
Don't
out.
Look
Don't
Up. Yeah,
look up.
yeah.
So walk left, turn around,
So-
shoot bullets.
Walk Up. I actually don't. I remember being very frustrated with that movie in the in the beginning.
Hold it, move around a little bit, and you maybe shoot his spine. What was the moment? First 5? Yeah, like up and down. Yep, exactly like that.
Okay, so the very first, the detection of the asteroid was pretty good. It was pretty good. The thing that frustrated me was, all right, you're in a telescope and you're trying to detect something very faint, right?
Oh, there it is. Go.
Oh, yeah.
Walk right, find a door.
So if you go back and watch that movie, they're in a telescope and they're in the same building as the telescope, which you don't want to do. You don't want to put a warm body where the telescope is. It messes up the atmosphere where you're trying to observe. Second, they had the lights on. They're trying to observe.
Faint signal.
So it's like, are you kidding me?
They have the lights on.
I can't even get past the first 5 minutes.
Maya has written so many angry letters to the director of that movie.
Why am I collecting gold? I don't care.
This is civil forfeiture the level. Free gold. All right, here it is. The door. Nope, get to the 23 minutes and 23 seconds.
But that's it?
Yep, that is it. You've won the war on drugs.
Oh my gosh.
You solved it.
All right, but after they are in the same building as the telescope, and after they turn on all the lights and make the observations, then everything else was interesting. So, like the way that they were calculating the orbit,
the science was sound.
Yeah.
It's such an uncomfortable movie because it, like, COVID and everything just like pinpointed exactly that, and they captured something that's just. Yeah,
it was really good. It got really good fast for me. It started really rough. It was pretty comical. Like, how bad it was. My wife was like, "What?
Yeah, why are you so angry?" That's amazing. They got the lights on. Can't you see it? That's awesome. You just walk out of the theater like, I can't believe this. All right, your time was 23.
He has a spreadsheet that he's entering this into.
Oh yeah, no, I shared on Discord if anyone wants to see it. So you got 1, 3, 4 faster
Wait, is someone
than
did
you.
it in 10 minutes?
Oh, I did it in 10 minutes.
Oh, okay.
So I used to be the world record holder in this, actually.
No kidding.
Yeah.
Wow.
It started as a joke, and I committed to beating the world record, and now I'm second place. So you are.
All right, hold on. I want to ask you. So I have a family member who actually makes quite a bit of money on Twitch, speedrunning things.
Wow.
Yeah. Have you?
Oh,
have
no.
You been, okay.
No, I only stream this. I don't stream my speed running at all. So you are 13th out of roughly 40 guests.
Oh, that's not too
That's
bad.
not bad.
That is, I redeemed my horrible play. First, there was the bunkers that I did bad at. Then I mangled chess.
But Ted Kohlberg beat you.
Oh.
Colleague in physics.
Yeah.
But you did beat, who else?
I
Who's
beat
in
Ryan.
physics? Ryan Bombach.
Yeah.
Rachel Yohei and Hanwei.
Yeah.
And David Collins.
All right.
So you have bragging rights on several people. All right. So we have, I think we can safely call it quits. Do you want to put your initials in? It's the satisfaction of retro
Do I
gaming.
really?
It won't save, but.
Oh, well then no.
But do you feel like you accomplished something tonight? Yeah. Yes or no? All right. Tell Dr. Collins he got smoked. Show him the YouTube video.
Will do.
Give him credit. All right, everyone. Thank you for joining us. Ask a Scientist Gaming. If somebody has suggestions on who we should raid, throw those in chat now. I'm gonna check who's on the science subreddits and see if or not Reddit's Twitch and see if we can follow those guys. But yeah, thank you for joining us. It's a journey. Every single time we do this, this is a journey. It's a thank you for the questions. Mayo, thank you for joining us. This is, again, a weird request, and I'm really glad you did it because I had a lot of fun tonight and learned a lot of things. Any parting words for the audience?
No. Love is a fifth force,
Love is
and it's the
fifth
strongest
force.
one.
What I love is that that's going to end up being right. We were all wrong our entire careers, and yes, maybe the days before we die, we'll learn love is the most powerful force in the universe. But anyway, thank you all for joining us. And actually, next week we have a special guest, Johan Simone, who's a professor from University of Southern Mississippi, is a guest speaker at Florida State University. He's going to join me Wednesday night before he gives a seminar on Thursday at FSU. So we have, again, a guest next week. Yeah, exactly. Somebody I know personally. He's coming to FSU and he
That's awesome.
volunteered for this. So if you have guest speakers that might want to do this,
Okay.
let me know. I'll get them
Will
on the
do.
schedule. And so
Well, make sure they do it before they give their talk.
yeah, exactly. They show up hungover and meet with our faculty and give a talk and research. That's my goal, really. I'm just disruptive. So yeah, Johan Simone, he's he's in the Department of Polymer Science and Engineering. So he does polymers for designer things like photon up conversion, light conversion, mechanical forces, all sorts of stuff. So he'll be our guest next week. So please come back and join us. Then a couple weeks, we'll be back on our normal schedule. But Maya, it's been a pleasure. Thank you all for joining us. It's always a good time. We really, really enjoy it. But yeah, Ask a Scientist Gaming, thank you as usual, and until next time.